across the surface of water. So there is no curvature, period.
Well, I think the claim that it just becomes a horizontal plane is definitely misguided and just.
No, it's not misguided. It's absolutely. It's demonstrated, dude. It's demonstrated. We have demonstrations.
Anything.
Are you kidding me?
I can demonstrate the opposite in many cases around with all water.
No. You can't listen. Every time you see a large body of water,
but it was
listen. A large body of water displays no convexity. So when you say that you're going to show convexity, I want to know that the Earth's surface, according to like what we see with lakes, oceans, ponds, any large body, that they display any convexity whatsoever. I want you to demonstrate that right now. If you're saying I'm wrong, do it now.
I mean, okay.
Yeah. Plus, with all the winds and the tides and the birds splashing around in the water, you can't use your glass in a cup.
The vast majority of
surface tension dome.
Pressure, it's due to the curvature.
It's like he doesn't hear someone else speaking. He's just going to start talking like he doesn't.
Well, I don't feel that type of respect towards me, man. I'm sorry.
So you're going to explain. All right, yeah, you didn't hear something. You can be cordial.
It was an accident, bro.
Nothing is known, but except when his feelings are hurt.
Treated cordially. That's not my.
Are you using physics?
Now he knows things for a certainty. All of a sudden.
Hold on, let me just get him to agree on the physics of water. So, are you saying that physics demonstrate that there's a curvature?
You're saying that there is a curvature? I mean, physics.
No. I'm saying that you are saying that the physics describe that there will be a curvature.
No.
Okay, then that's my point. Therefore, my point stands, and yours doesn't, against the critique that physics describe that the Earth is a horizontal plane. We're going straight from physics, not to your explanations. Straight from physics.
Yeah.
And that's what I'm using. What are you using?
You're not allowing us.
What are you using?
Physics.
What are you using?
Physics.
Then demonstrate with physics.
But you're not letting us use physics between the two of us. We can't use physics because of you.
Go. Demonstrate it.
Okay. So again, when you have glass and you fill it up to the top, I'm assuming you're going to interrupt me here because I want you to. Why is that not a demonstration of a curved surface in the water?
No, don't ask me a question. Demonstrate how physics demonstrates that the surface of the water is curving. I want you to show that with physics.
Well,
and somewhere there's a resource. I've given you. Listen, hold on, Creanix. I've given you hydrostatic equilibrium, which you can look up. It's in LibreText. It's in physics, and you can find this anywhere.
Hydrostatic equilibrium creates a horizontal.
No, don't ask it that question. I want you to look in physics, anywhere in academia that shows physics describing hydrostatic equilibrium. Don't ask the question. Look for the example of what it is. What it is important. What is hydrostatic equilibrium?
I'll go to Google Scholars then.
Any academic source, yes.
Hydrostatic equilibrium. I'll just press enter. Okay, so it says here hydrostatic equilibrium and stellar structure in F of R gravity.
Stellar structure? No.
Yeah.
No. We're talking about the physics of what. Go into LibreText. Does somebody have the link to that?
This is pretty similar. This is hydrostatic equilibrium fluid interfaces. That's what this says.
I don't know what that is.
Problem of
pertaining to the physics of water specifically.
Yep. Every single thing I've said has been doing that. So I'm just wondering.
No, it is not. No, it is not.
What's the
talking about stellar? You're talking about we're the classification of it being on the surface of the Earth. Yes. Completely tangible and interacting with, because that's what physics is. We interact with things tangibly. We're not doing something outside of the Earth system. Yeah.
Sometimes in my.
No times. We're only doing things with things here on the Earth. So go from the vantage point of physics that demonstrates on the surface there's any convexity. Go.
Okay, most surfaces do have convexity. I found this article.
No, I don't want you to keep telling me your explanation. I don't want you to tell me. No, show me a link.
Yep, so I have a link here. It's called General Solution of the Problem of Hydrostatic Equilibrium of the Earth. Is this title good enough?
What did you say?
It says General Solution of the Problem of Hydrostatic Equilibrium of the Earth.
The problem?
Yeah, because when you're practically doing stuff on a large surface, hydrostatic equilibrium is going to always play a factor.
Let's see what it says. Just post it. Just post it.
I haven't read it yet. I'm just trying to find one that you think is good enough.
OMG.
Or something.
So you don't know if physics described that the Earth's surface is curving based on the physics of water.
I do know.
You just said it right
I'm not allowed to know in this conversation. I'm not alled to know. Right?
No, just listen to what he's saying. You don't know whether or not it does, but in reality, all the things you experience, like when you put water in a cup, in a pool, in a puddle, it lays flat. You're arguing against it. Before he demonstrated.
Before he skedaddles, he said that physics described the surface of water to be curving. He already had something in the hopper. Now he's looking for the answer, which shows to me he doesn't understand what we're talking about. He doesn't have a rebuttal to hydrostatic equilibrium, showing that the surface of water having surface tension describes the surface of water being planar and horizontal and flat. So now his rebuttal is, let me look for the answer to my rebuttal. No, you're not going to. You've already gave up the ghost. You don't have a rebuttal. You're looking for it right now, and that's not going to work. Sorry. I've unmuted you because the point's over with. You already. You can't come back. You can't come back from the grave.
We can move on from the point.
Yeah.
Let me just.
Yeah, it's over. It turns out to be an empty can.
You don't have an answer.
Can I
You
please-
don't
You
have an
can only
answer.
move on after you
Could I-
concede, Creanix. Only after you concede. Only after you concede. Only.
Are you sure? That seems to disagree with him.
Yes. No. Concede because you didn't have an answer. Do it now, please, for the audience.
Could I please say anything that I want to instead?
You
No,
wrote
you
it
have
out.
to concede that you didn't have a rebuttal to what I gave you. I gave you
That's kind
physics.
of what I
You
want
gave
to
me
say, though.
nothing.
I had a rebuttal. I had a great
You
rebuttal.
gave me nothing.
I wasn't allowed
You're
to
gonna
get it.
either concede or sit on mute. It's up to you, dude.
I mean, we didn't have a real conversation.
I mean, you were
You
looking
concede
at what
that
he
you didn't have
asked you
physics to
for.
describe.
No, I
just concede it, so
wasn't.
you don't know.
He forced me to look for it. I didn't look for it. He forced me to.
Yeah, because
You
you
said
didn't
you-
know yourself. All you have to do
You
is
said you had
concede
the
at this
answer.
In
point,
all
and
of
then we
examples
can
of
move
me
on.
interacting with
Yeah,
any water
just
in all of my
concede, and
entire
then we can
life,
move
the
on.
water surface.
It's just bloviating. You need to concede that you didn't have the answer. You thought you did concerning physics and the surface curving. You didn't have that, dude.
Just concede, and we can move on, bro.
Wasn't given something I can really concede here. Like, what am I conceding?
That you said physics.
Forces
You said that physics
flat.
described the surface of water curving. That's what you said.
Yes, it does.
Physics
It does all
described.
the
Yeah,
time,
no,
yes.
you didn't have it. You didn't. Where? No papers were presented. Nothing was
I
given.
tried.
All right, do it now.
No, wait. No, he's looking for something. We're not telling you to look for something. We thought you already knew that that's what physics described. You didn't know
Yeah, I
this.
do. I was already shown many articles.
No,
throughout
you
my
were
life.
looking. You were looking. That's what you were doing. You were
I
looking.
don't
You didn't have
them
it.
ready.
Yeah, let's
No,
be
you didn't know
honest.
where
You
to
didn't
look.
know anything. You were reading a
You
bunch
didn't
of
know where to look.
I
explanation.
can look. The best part is that I can look through all these scholarly articles and I'll find other people.
See, he's looking for it. He's looking for the have it. Right now.
Field.
Just concede you didn't have a rebuttal, and then we can move on. It's not,
I did
not a
have
big
one.
deal. It's not a big
I don't know
deal.
why you want me to gaslight me into believing
Yeah,
something that's
you
not true.
didn't know it. You had to look it up. That's the point. Do you understand? Just concede that you didn't know at the time, and you'll figure it out later, and we can move on.
What am I claiming to not know?
The surface of water curving with physics.
No, I know that the surface of water curves.
The third time you said that, you're losing the plot,
See,
sir.
physics is just a model. Like, physics isn't truth, right? Physics
Okay,
just
here we go.
how things work.
Wow.
And
No,
if
bullshit,
you
dude.
interact with reality, you will
Look
see
at how
that
he's
water
running
is
away,
always
guys.
perfect.
Wait,
I'm not running
Creanix,
away.
slow down. Physics is based on reality, the physical and natural world, things we
Correct.
can test and
Absolutely
manipulate.
right.
So stop talking while I'm talking. So what are you talking about?
I'm talking about the fact that no matter how much we model these input-output mechanisms, it doesn't mean that we actually can claim a truth statement because it's based off the language that we standardize just to create the system that is the
Oh,
model.
science doesn't prove things. We can't use the
That's
science.
how we
Never
run
has,
reality,
It
guys.
never
proves
has
things.
proved anything. That science has never
Without getting
claimed
off into the
to.
weeds there,
Scientists
you just
claim to
said
prove
you just
things.
said that the bodies of water are curving. So could you show us who's measured a curved lake?
Yeah, sure.
Cool. Post the measurement in the chat. A curved
Keep
lake.
quiet for like 30 seconds, and he's going to start
Okay, I
talking and
gotta-
not present that thing we asked for.
No, I will. That's an easy one.
All right, yeah.
Amazing. Well, we've been waiting for a while, so you'd be the first one in like 10 years.
Well, I don't doubt that. A lot of people are stupid, man. Most flat earthers are smarter than average people.
Well, it's not really a question of people's intelligence. It's just a question of how the surface measures.
Delta slopes. I don't know what a delta slope is.
Did he find it yet, or is
He's looking. He knows it's there, but he doesn't know exactly where. Someone's done it, but who?
This is the annoying part about Glob
I think this
recycling.
one's good enough.
Good enough.
I
Now, is
think
it a measurement of
for you
curvature
guys.
before you post it? It's a measurement of curvature?
Has it involved? Yeah, it mentions curve all the time.
Has it involved? When you say has it involved, does that mean it's assumed?
No, it means that it's not the main point of the article.
Okay, well, I'm interested in a measurement of this. Is that in there?
negative? Just a bunch of words and diagrams, and then there's a
Well, let's see.
triangle
Give him
diagram.
a chance.
Do you want,
Who does
do
it
you want me to
say
look through
measured
for
and how
a
much
measurement of
curvature did? Yeah, well, that's what you were having to evidence, wasn't it?
No, I thought that you want the
Yeah, no,
measurement.
that is
oh,
what it
okay,
was.
yeah, no, I'll find just the measurement. Okay.
So like a curved lake.
Yeah, we should have a diagram or a picture of the curved lake and the numbers to match it. I know it damn well better be longer than 32 miles, like Lake Okeechobee here in South Florida. I'm just saying.
Well, what's interesting is a lot of the things that talk about curvatures, like.
Did you find it yet, though?
Got it? You don't care what I have to say unless it's that?
That's what we're waiting for. That's what we're waiting for.
But don't need to be impolite to the guy. You can have your statement if you're still looking.
My bad. Go ahead, Creanix.
Right.
What were you saying? Why you're still looking for that lake that's pending?
Well, what I want to say was what's interesting is a lot of the things that I'm like finding when I look stuff up is always like about a small body of water. It's like, can we get the curvature from like 2 feet of water? You know, those experiments.
Oh, that's
2 feet
crazy.
of water.
That's
No.
crazy.
Yeah, well, they are assuming that you can do it in a large body of water already, so they're moving forward.
Oh, so you can't find anyone who has done it yet?
Well, I found full calculations, and when it is applied, it's just a measurement, right? You want an actual measurement done.
No, we want the actual proof of it, not an assumption and calculation.
Which is a measurement, in this case.
No, measurement and an assumption and calculation are different.
Right, you're looking for a measurement, is what I'm...
Yeah, like someone measuring a drop over the distance of a lake. The curvature that's being assumed. We'd like to see that measured, proven. Otherwise, the whole Globe story's out the window. Take your time, though.
Okay, I think this is good enough right here. It's, I don't know what the credibility type of the article is the thing. But I mean, it has the measurements, even though it's not a scholarly article. There you go. And when you decide that this isn't good enough, can I please understand why rather than just being told I'm inadequate?
Well, explain what was done.
Well, if you scroll down when you go there to choosing target heights, you can see a good visualization of how they did it.
And what does it say?
They put equal length bars, and then on the surface of it, they did taller bars, and they put them at different points in the lake. And they then saw how those bars should be if the Earth is flat or if the Earth is a globe.
And does that count for perspective and angular size change over a distance and all these things?
Well, since the bars are so huge, you don't need to do that too much.
They're still going to be subject to perspective and angular size change,
but
aren't
negligibly.
they? What do you mean negligibly?
So
based on what? What's that based on?
Well, my
Are you saying they weren't accounted for?
If you see bars in a lake, and they're like 10 feet tall, and you put a bar
How far away are
9
they?
feet tall, kilometers.
How far away are they? What?
Kilometers.
Well, then that's definitely going to not be negligible. So, are you saying it is accounted for or it's not?
It is accounted for, yeah, because of how this is done.
Okay,
it's not
could you show us where they account for it in that?
In the size of the bars. See, when bars are when the difference...
So how did they account for it? Is it in the map or what?
The size of the bars. So see, when the size of the bar difference is about 3 kilometers, right? So you have a 9.5 kilometer bar and a 6.4 kilometer bar, and you set them up on points that are 3 kilometers away, you're going to be able to see that one is taller than the other, no matter unless you're getting low on the ground, but I'm sure they wouldn't want to do that. The measurements were done, I assume, from the side. I don't know which direction they did it from. Calculated heights are calculated. Okay. Just more calculation. Ooh, okay. If you scroll down on the article to size and placement of the targets, it'll show you a bunch of different
Wow.
things, the target has 2
It's got involved with Jesse, Soundly, and Water Bislin. It's a who's who of anti-FE retards.
Absolutely.
Oh, it's this, the Rainy Lake one. That's funny.
I'd just like to apologize to AV for calling him a name. That was kind of in the moment, and I didn't mean it.
You're good, Mateos. He doesn't take it personally. You're good, Mateos. Just try to be more cordial in the future and try not to interrupt people.
Not to be like me.
Yeah, that's all. I'll chime in when...
Oh, here we go. It says, targets the same size appear smaller with increasing distance. To counter this perspective effect, the targets were built in such a manner that their angular size as at the observer is about the same. This way they appear the same size no matter how far away from the observer they are. Target 7 is about 4 times larger than target 2. So they took perspective into account in their calculations.
They're squashed. So that's not going to work. Have you got anything that's like a measurement with a laser or something? Something that makes a straight line reference?
How could you do it with a laser?
Well, if you had, say, a target 10 miles away from you, then you just work out the height of the laser versus the target, have them roughly equal. And
the target has to be floating on water?
Yeah, no, on the opposite side of a 10-mile lake.
Oh, yeah, just be on the other side, yeah. Okay.
Yeah, and then if that's supposed to be behind the curve, then the laser wouldn't be able to hit the target. And you would see it going over you. Overhead, right?
Why can't we do that with the ocean?
Well, do it over any body of water that you can get a decent distance with. Feel free. So has anyone done that? And measured a curve so that the surface is dropping
Well,
away
you
from the
can't,
laser
you
beam?
can't measure a curve by doing that. You can definitely like see if one exists or not.
I'm sure
Well,
that's
yeah,
what he asked
okay.
for.
So, well, how would they show that it exists or not?
Well, like you said, if
It'd be
the
blocked or it'd
laser
go
can't
sailing over
reach
your
the
head.
target, that means there must be mass
Okay.
in the way, right?
So people have done this and they can hit the target. So what does that mean?
People have done it and they can't hit the target.
Okay, who's done that?
With a laser. With a laser.
Yeah, so
Who's done it with a laser?
who's showing that laser sailing over their heads, coming from the horizon?
Sailing over their heads.
Yeah, because they're supposed to be below the laser at the other side due to the curve.
Wait. So your experiment is to have two equal sized targets on one side of a lake and the other, and you're supposed to shoot the laser over the curvature. Well, as parent.
Well, no, the curvature would block it. You wouldn't be able to hit the target, would you?
Right. So why is it sailing over their head?
Well, because if they're on the other side of the curve, it would be going above you. To your perspective, you would just see the laser come to you
it wouldn't
overhead.
reach you because it's getting.
Well, if you aim it slightly over, yeah, if you aim it just over the horizon, right?
With that much distance, that's hard to do with a laser.
Yeah, that's why no one can demonstrate there's any curvature with any kind of
Well, if the laser can't reach the target, right?
Well, there could be a number of reasons why it doesn't, but it would have to be never reaching the target if it's due to curvature. But that's not the case.
Yeah,
People do it. I just posted one in the chat earlier, 28.6 miles. I'll post it again for you. There you go, watch that.
Right.
So measure a non-existent drop over distance versus non-existent measured lake drop over distance.
Jayo, you're pinging in the chat. What's up? Yeah, I ain't reading all that, Jayo. Just unmute your mic and ask in the voice chat. Or someone else can answer it.
Yeah, basically he's talking about a 24-hour sun in Antarctica. And things in the sky don't dictate the shape of the ground. If you're new to flat Earth, you should know that the surface is measured flat, traverse flat. They traveled across a flat plane to get to Antarctica.
So I found an issue with the video, and that is that the lake isn't attached to an ocean. So the land lumpiness
Doesn't
will
matter.
change the curvature. Yeah.
No, there's no curvature. No, because it's just the body of water. How much curvature does the Globe model claim exists over 28.6 miles?
Well, they don't claim anything exists over that length. They
Oh,
claim they have
really?
a model that helps them get a good idea.
You
Of
sure about that? So what they're saying
I'm
it's so
absolutely
according
sure
to the
that
Globe.
no one has ever, according to Globe, no one's ever claimed that you actually get a certain value if you do that much.
That's a lie.
Wow, why are you? Imagine saying that so confidently when you clearly got no clue. That's amazing. Where did you get that
Well,
from? Who told you
I do
this?
have a clue. Well, I get that from listening to scientists. When scientists and all these other people,
The scientists
people who are
say
in the
this.
field,
This
who
is what
do
they're claiming.
experiments, what
This
they
is what the
say is that
scientists
when
are
they actually
claiming.
get to the real life world, it's always going
There's
to
no
be
curve.
homogeneous and lumpy, right? That's why I
Wow.
can never agree
Yeah.
with
So do me a favor.
hydrostatics
Do me a
being
favor,
flat.
Creanix.
Because if
Creanix.
Hold
am I
on, hold
supposed
on.
to just get interrupted in this case?
Hold on. Now, this because we need to address this. So, Creanix, do me a favor. Go on Google and type in Earth curve calculator. You do that?
Yeah, I've already done it.
All right. So, how much curvature? So, why would you say that 28.6 has zero curvature when you know that's not the case?
Well, it sometimes does. Sometimes it has a
No.
concave
So, what does the curve calculator say? What does the curve calculator say over 28.6 miles? What's the drop in
What's the
feet?
curve calculator? The
Geometric.
curve calculator says that's H1, hidden height 512, 513 if you round. Yeah.
513 what?
That's what it says. Feet.
513 feet.
Yeah, that's what it says.
So not none.
I didn't say that it would just be none. I'm
You
saying
did.
it can be.
You said
No,
no
it
one
can.
would claim it's any value.
Yeah, no one would claim it's any value. That's absolutely true. That doesn't mean
Yeah,
that would
it's
claim the value
513
0. That would
feet.
be
That's the
claiming
value.
Yeah, no one claims that value.
You just read it off.
Yeah, this is a
So you're saying
calculator.
that's wrong, or is that wrong?
No, I'm saying this is a function based on a model.
Oh, but it's not true in reality.
Yeah, no one's ever claimed that. If they did, they're
Alright,
horrible scientists.
so that curvature doesn't exist in reality. That curve model's claiming.
Those numbers won't be accurate to reality, and they can be way off from
Listen to him
reality.
tap
But they
dance now.
usually,
Ah.
this isn't they usually are more accurate when you're doing like ocean
You
reading.
don't hear that? Tap, 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 tap.
Okay, well that's fine. Yeah, you don't. Okay, so those calculators are wrong, and they're based on a 39-59 mile radius ball.
They're not wrong.
And you're
They
saying
just
that's
don't
not.
reflect
Oh, so
reality
they're not wrong.
because reality's
Oh.
contexts are much more complex.
So it's not. It's not wrong, but it's not true in reality.
Correct. Because
doesn't
it
make any
claims to be
sense.
true in reality, it can't be wrong.
It's a
Because it
contradiction.
claims to be true in reality. It's not a
So
contradiction.
it's not true in reality.
It doesn't claim.
Okay, so it's just a fantasy. Okay, so you agree it's just a
It's not
fantasy.
just a fantasy. It's based off of
It's not
reality.
true.
But it's not.
Well, no, you just said it's not
going to reflect
reality.
No, it's based off of it, like all science.
Okay, what do you mean? What do you mean?
Could I get my full time to explain what I mean? Because it is very coherent.
It's very incoherent, but please explain it anyway.
Stop the cap.
So when we make a model of something, it's going to not always reflect reality fully. In fact, none of our models can. Most of the models we use for calculating like Earth curvature with large distances, they actually need an oblique spheroid mathematical help because the model we use isn't perfect. And even then, that doesn't mean they're going to get the right measurements.
So how much? So when the model says 513 feet, what are you saying? Are you saying that's like off by a few feet, or it doesn't exist, or what?
I would say that how off it is depends on the actual context of the experiment. For this case, it would be
Well,
the
over
lake
a body
itself.
of water.
It would be
Yeah.
the thing that disagrees. The lake itself.
So the body of water. That's not got topography to worry about. It's just a body of water. So what's that going to be?
So it actually does change based off topography, right? That's how lakes work. Their borders not only change, but how
What do you
convex
mean?
and concave they are also changes based off of the water, where it is.
What do you
and
mean
how
based off the
land
water?
under it.
What are you talking about? What do you mean? So you think the surface of the water is going to change based on the land under it? Like if there's a hill underneath the water, the surface of the water is going to have that hill.
No, I'm saying that if two ends of a body of water, like let's assume that the Earth is curved, we should see curvature, unless one of those sides of the body of water is elevated about 500 feet, right? That doesn't mean both. That doesn't mean one is elevated 500 feet. It could be that both are elevated
So your level of the lake would be diagonal.
Well, diagonal doesn't come into play with these calculations.
Yeah, you're
Okay,
talking
so-
about a slant lake from a cliff down to the waterfall, dude. Come on.
No, I'm not talking about a slant length. I'm talking about possible.
That's what it sounds like you're talking about.
Because I'm saying there's
If there's
another example
500
where
foot cliff
one
on
is up
one side of the
300
lake and
other
nothing
is
on the other
200.
side, it'll pour away.
But these are
Well,
the
no,
observer
not
and the
if the other
laser.
side is.
They're just on the shoreline. They're just on the shoreline. They're not on a 500-foot cliff.
What do you mean they're just on the shoreline?
Each observer in the laser test, one side isn't on a 500-foot cliff. They're both
They seem to
level at the shoreline.
higher elevations than sea level. I mean, they're in a mountainous region.
Yeah, and they're flat at their surface, bro.
No. Gregory.
Are they
Ryan.
measuring sea level by the lake that's there? Because that's not okay.
No,
No, that's not how that works.
How do they
No.
measure sea level then?
no, don't. We're not getting off this.
We don't have to.
The laser isn't being obstructed by any curvature. That 513 feet you just read off the calculator isn't there. How do you explain
Yeah,
that?
but because the calculator doesn't represent reality. I would say there's possibilities of parts of this lake being
But
at
there's-
higher
but-
elevation than they can
But
calculate.
this wouldn't even be showing 20-foot curvature.
Yeah, the curvature that
It's
you would
showing
actually
none.
measure is completely based off of the factors, the context that they're in.
Now
based
that's
off
just
of the
meaningless.
model.
Now you're just saying
What's with all
meaningless.
these
No, I'm
words.
mental
saying- what I'm saying
gymnastics
is
and
that science
apologetics
is
for why
based
we
off
can't
of
be a
reality.
curve? I don't know what that's
Reality
about.
is not based off of science.
How's that laser hitting the target on the other side?
Because there's nothing
Apologetics and
obstructing
mental
it.
gymnastics.
Hold on. That was the question.
Because there's nothing obstructing it.
Okay, so there's no curvature obstructing it.
There is no curvature that is obstructing it, correct?
So there's no curvature over 30 miles.
That's not exactly true. There's just no curvature that obstructs it.
So there's no. Yeah, that's over 30 miles. 28.6 miles.
Where's that 500 and some feet? That's what he's asking.
Yeah, you just said it. There's no obstruction.
Yeah, I don't even know if this calculator is right. I want to actually do the equations myself. But even if it is right, let's
Good
assume
for
it is
you.
512, right?
Yeah, but not in reality,
I
right?
could explain it in many different with many different factors.
He just realized he flat smacked himself.
Yeah, you couldn't explain it in any way other than like you already explained it. There's no
Well, no, I'm
obstruction.
thinking that there's a possibility that this calculator is probably discredited. If it's
Yeah,
not,
you
that's the
just
reason.
sent
But even if it is 512 feet, there are still cases.
the calculator that calculates the globe for you. Now the calculator's wrong.
We don't know that.
Well, that's fine. That's fine. I
don't know that.
can
I don't
go
know
with
if
the
the calculation
calculator's wrong. The calculator doesn't reflect reality. Exactly. That's exactly what we're showing you. So that's fine.
Right.
There's
I've
no
already claimed
obstruction,
that.
like you said.
That was
Yeah,
my
there's no
claim.
obstruction, like you said. So yeah, so there's no curve over that 28.6 miles. So there you go.
Minus the objects and such, yeah.
So the water's flat.
That water isn't exactly flat. No water's exactly flat.
Well, it's not
But-
curving around a ball, like you just said.
It's probably not curving around the spheroid of the Earth. No, it's
Of
probably.
course, because it's not exactly. Welcome to flat Earth. Like that.
It doesn't mean I'm flat Earth. That means in this one context, it does. You cannot see.
Yeah, you're just acknowledging the reality of you're acknowledging the reality of Earth. I know you're going into overdrive.
maybe
Conclusions, man.
maybe you're going for the.
Yeah, there isn't a 500 or so feet obstruction in the water.
mean-
You can see clear across the lake. So yeah, there's no obstruction.
how
The
many-
water's flat.
How many 30-mile flat spots make up a globe?
Wow.
So this is maybe what you're defaulting to. Maybe you're thinking this is just. Maybe you're thinking this is just a flat lake. This is the only
40
flat
miles?
lake.
Yeah, they probably have like tons, knowing the geography.
Maybe, possibly, probably.
Maybe they've only got
I mean, I
flat
haven't
lakes.
gotten any of them.
Maybe we've only
Well, no,
got
they
flat
don't only
lakes,
have
and that
flat
would
lakes.
be.
I mean, I sent you
Oh, okay.
that shows the
So could
curvature
you
of
show
lakes,
us one like this with a laser that demonstrates the curvature then?
Why must it? I mean, okay, if it must be with a laser.
Yeah. Something with a good, reliable, straight reference.
I mean, I could have swore you explained that every time they've done this across large bodies of water, it measures flat. He's going to still find one that doesn't.
I don't think I would assume that every single lake is flat. I mean, I know based off of physics that that's not true. Not based off of a globe Earth theory. I don't think it has to be the curvature of the Earth that causes it. I just know that's not true because of physics.
Yeah, that's the
No,
globe Earth theory that is based off of that you believe in, not the
No,
reality
it's
and
not
physics
based off
of
of
water.
that theory. No, I'm telling you, it's based off of physics. Like it's
No,
literally.
the physics,
Yeah, I'm
the
telling you
physics,
it's not.
physics of fluids says that a fluid at rest will seek level. That's what physics
Yeah, but
says.
it also says that a fluid at rest is never truly at rest and is always volatile. The surface of water is constantly.
Well, it's always seeking level. It's always seeking level. It's always seeking level. I mean, you fill
but
up
that doesn't mean it
a
ever reaches
container with
level. It
liquids.
doesn't ever reach level. We know that. It's very obvious in physics. Like it does never reach
Nah.
level. There's always
Yeah,
wind.
So
there's
there's
no
no such thing as 0 degrees. Water. So there's no such thing as 0 degrees then, water level
In
for
Kelvin,
everyone?
yeah,
There's no such thing.
Kelvin. Oh, 0 degrees. Yeah, there's no such thing as 0 degrees water level. Correct. There's no such thing.
Yeah, so there's no
There's a
reason to
slope
talk
of
to
it
this guy
randomly.
because he doesn't know what he's talking about then. So there's no
do.
reason to continue talking to
I
him.
don't know why you sound so confident in all this.
Well, because this is stuff that's standardized model. You know?
I mean,
This
this
is
is
the same
he's
guy
just
who-
looking into. Of course, he should be extremely confident. He's looking the
Give us-
answers up. He should be
give us a
I didn't look
citation.
this answer up. I'm only confident when I'm not looking it up.
Give us a
No,
citation that says water's never level.
You don't need one. Look at real life. Like
No,
look
This
at
is
no,
the
real
same
water.
guy who
Get a
balked
cup.
when he was asked for when you were asked for surface curvature. You balked. You're
I
the
did not.
same guy.
I would never run away from.
Yeah, because we went a big full circle to this.
I would
You
never.
flat
Someone just
tapped
asked you to
yourself.
show
You
them
didn't
curved
like
water,
it.
and you said, "Look in reality." When in reality, you never see curved water except for teardrops
Literally,
for
that lake
ballers
was extremely
or
curved all over the
raindrops
place.
halfway
That's
through my
curvature there.
sentence. I don't know what's going on.
Because you're claiming stuff that's not true. That lake that we just saw from the video you just sent shows curvature in the video itself. Like
No,
there
you
is
just said
curving
it
of the
doesn't.
water
You just said there is no curvature
it's
of
not
the
showing
water.
Earth curvature. Not at all.
Yes. See, it's just going to take you some time to internalize this realization and realize that it debunks your entire belief in a globe.
I would never let
This
one
one,
location biasly debunk my belief.
This one demonstration of water not curving in the manner claimed by the model of the globe is enough to debunk the globe in its entirety and all of
No, that's a
heliocentrism.
crazy claim.
And he's
No,
sugared and
no.
can't help but
It's
interrupt.
just, I'm afraid it's just because you have not looked into it. You don't understand it. That's why
Well,
you
if
don't
I had more evidence,
realize
sure,
that
but
already.
this one piece of evidence cannot be.
Yeah, well, that's why I'm saying. That's why I'm saying you don't understand it yet because you haven't taken the time to go and fully internalize this and then do
Well,
the research.
I have assumptions that fit with both models. I will have to do the research. You're right about this lake. But if I can find
Not
a
about a
lake,
lake,
that shows
about water
curvature-
generally, everywhere.
No, it would have to be this lake.
Well, you can do that lake, you can do any other lake, you can do any example of a body of water in
I already
history.
know all bodies of waters
Feel
and lakes and even calm ponds have curvature on their surface. That's not like a
Not Earth curvature, though, do they?
Not Earth curvature. Not always.
Yeah, there you go.
Okay,
So
dude.
welcome to flat Earth.
Yeah, and fishies splash around at the surface.
Yeah, and that creates.
But we're not saying that they're
he
always
said,
glass
yeah,
like.
that
creates curvature.
And you know we're not claiming it's always glass like. That's not the point. All of these disturbances that you're talking about, they're in reference to the horizontal. So
Yes.
that's it. Yeah, the horizontal flat. There you go.
Yeah. Okay. So
Awesome.
your claim isn't that
Okay.
hydrostatic just makes it flat. It's that it seeks level.
Yeah, I mean, with wind and things, it can be
Okay,
rippled, but that's not our contention. The contention is
do
it's
know
not
that
wrapping
even
around the
without-
ball.
And you know that even without winds, you'll still have oscillations constantly at the surface, right?
Well, I don't know what like vibrations, like Indetectable
waves.
disturbances? Sure, if you want.
Detectable, but not by the naked eye.
Yeah, but you
Is
want
any
to assume. Who cares?
You can actually detect it with temperature. You can feel it coming off of it. Sorry, that's interesting to me. All right,
Well, either way, it's the Earth curvature that doesn't exist, and that's what's needed to exist for the globe. So that's our point.
So apparently, I found a video that talks about laser refraction. So from this thing's understanding, it's saying that this is a different thing. This is something I've read.
So it just curves
saying that
perfectly
that
around
lake-
the ball. Amazing.
No. It's not that it curves perfectly around the ball. It's that it refracts all throughout the water molecules.
Creanix.
Okay.
So it gets
that
buried.
still wouldn't allow it to traverse 500 plus feet of curvature.
No,
That
it would if it's all with water molecules.
Oh, it would. So it is curving perfectly around the ball to then hit the
No,
target.
I don't know if it's perfect. Like I said, you're not going to have perfect curvature, and even the Earth's curvature isn't perfect itself, right? Like.
So is this your new position? That the no detection of curvature is actually there is curvature, but the light is imperceptibly bending around it.
My new opinion from this explanation, it attaching to my understanding of refraction physics, which I've done
Belief, if this is what you're talking about. Well, this isn't something you've ever observed or experienced.
I have
about a light bending around a curve. That's
the proposed mechanism. I understand. When I apply it, it does work. That's
okay. Could you show the demonstration of that? Show me the light bending around a curve. Can you show me that?
So that's why I brought up rainbows. Rainbows. There's many different types of rainbows, and a lot of rainbows they can actually be created just from one water droplet passing through a place. That's why it happens after rain. It's because there's a lot of humidity in the air.
But yeah, but that's not you perceiving things that are around a physical obstruction.
No, I've calculated how to use lenses to transfer light.
And lenses? No, this is through the air. This is through the air.
Well, air has a bunch of lenses in it, remember?
Oh, really? And the lenses are making it curve down and around a curve of Earth?
No, they're refracting them in every direction.
Okay, so it wouldn't be coherently going around a curve 500 plus feet and then allowing another person to see it.
No, it would. It's just that
it would. Okay, can you demonstrate that? How do you demonstrate that claim?
Well, I can demonstrate that claim with the understanding of how water molecules work and where they are in this case.
Okay, so post the demonstration in the chat.
Do you not want to just understand what I'm saying?
No, I don't want to just imagine your claim. I want you to show some evidence for it.
But okay.
Well, so far it is bending light around this curve.
Explanations. He can't present anything.
I can absolutely present all the science that makes this.
Okay, just show us.
Here's what I need. This is a well-part documented thing in physics that you can usually find something for. So now what else do I need? I also need to have this part.
So just show. Well, you could start by showing us a laser bending downwards in air.
I'm going to show you diagrams.
Spiraling.
Okay.
You're not even recanting to mainstream physics. You're just.
No, I am.
You're like a buffet dude right now.
No, you're making it up as he goes.
I'm not making it up as I go.
So rainbows are created by a combination of reflection and refraction and dispersion. You're
correct.
Yeah, it has no application to this.
It does because there are the things that cause refraction and reflection and dispersion all throughout the air above a lake.
Right,
so why don't we see, if there's refraction, bending light around the ball, why don't we see any dispersion?
Yeah, I'm going to go on mute for a bit, but Indio can pick this up for you.
Oh, we do. So if I look at a faraway mountain that's supposed to be around the curve, and it's blue on top and red on the bottom?
That's not how dispersion works. Because all of the different dispersion of different lights from different angles are all going to be reaching your eyes at different times, but continuously. So you're going to see a white.
Yeah, listen, it is how dispersion works because you have a temperature gradient, right?
Okay, yeah. From what? Okay. Temperature gradient from the top of the mountain?
So the refractive index toward the ground is less than the refractive index higher up. So that means the optical path of things higher than things lower will be different, right? So there's actually devices they make for telescopes called dispersion correctors, because if you look at Jupiter or a star, you'll see blue on top and red on the bottom.
Yeah, but you don't see that with mountains. And the reason we don't see that with mountains is because of all the different angles we are receiving diffused light.
What are you talking about? What angles?
Well, there are different water molecules at the top and the bottom, which all have different fractions of index. So they're all going to have slightly different wavelengths. So it would create a rainbow. However, it's such a minuscule one pinhole effect that any water molecule next to it, its light that comes towards you as well is going to resonate with the light that's hitting your eye.
That is word salad gibberish, bro.
What is it? How is that?
That is word salad gibberish.
This comes from my understanding of how rainbows work.
You don't understand. It has nothing to do with rainbows. With a rainbow, the light goes into the water droplet, reflects off the inside, and because the angle of incidence equals the angle of reflection, and then you have dispersion within the water droplet itself, when it exits, depending on the angle you are to the raindrop, you'll see a particular color.
Yes.
Yeah, which has nothing to do with this.
The dispersion is what causes the rainbow, yeah?
Well, the dispersion in your angle to that particular water droplet.
Right, so in this case,
if you see green, that means you're looking at that freaking particular water droplet at an angle, which would correspond to an angle internally inside the water droplet. I think it's 42 degrees or something off the top of my head.
Yeah. So with this, But with that one water droplet, there's also many water droplets around it, and them at different angles is what's causing the red, green, blue, purple, and all that.
Yeah,
However,
that's awesome, but it has nothing to do with this. Are you contending air is a water droplet?
contending that the air above a lake is filled with water droplets as if it was just rained, which is true because of the volatile nature of water.
Okay, that's fantastic. But how come you can see the farthest when it's the least humidity?
When it is what? Sorry.
The least humidity.
Well, I don't think this would work as well in least humidity because there wouldn't be enough resonance for you to actually perceive the difference in color.
Dude, the resonance has no application to this nonsense, dude. This is the word salad, dude. Nothing is in resonance here. Okay?
Water droplets create interference
Okay,
points. They interfere
so
with each other.
I'll give you two examples. There's long distance photographs taken across from the top of a mountain from the French Pyrenees to the French Alps. The distance is 275 miles. Also, 250 miles has been done for like almost 100 years. These photographs. Now, the time when you can see the furthest, when you can actually see, because you can't see it all the time. You can only see it in particular weather conditions. And those weather conditions are low humidity. And on top of that, right, secondarily, there's the Southern Ocean Sailing Guide. Now, what's unique about the Southern Ocean is that it says in that sailing guide, which is given out by the U.S. Geospatial Agency, is that it says it is not uncommon to see mountains 300 miles away. Okay, now to see a mountain 300 miles away from a ship, it would have to be 9 miles, 9.75 miles high. Okay, so there's no mountains on Earth that are that tall, so we have a problem. But the reason they say is because the air is remarkably clear and have no particles and has low humidity. Now, the Southern Ocean and quote-unquote Antarctica is well known for having low humidity. The average relative humidity is something like 25%.
Okay, so you've given the best arguments so far. You don't have to do this, but could you give me the article where they give that explanation so that I can see where they're referencing and look into it myself? You don't have to.
You want to link to the sailing guide? Sure.
Yes, please. That is very interesting. I want to see.
Yeah,
this is like the source of
humidity.
my new opinion, so I absolutely want to check its validity.
Well, what limits our vision is is what's called optical extinction. So it's a
Version from water molecules.
Yeah, well, it's not just that; it's dust particles, right? It's particulates in the air. It's depending on where you are. So
it's possible that water is better than dust at keeping the light going. You know what I mean?
No, it's absorption, right? So the light comes to you, right? So when you see an object in the distance, the light is coming to your eye or your camera or your telescope. And that air and anything in it absorbs the light before it gets to you.
Agreed. Or
how much it absorbs depends on how much absorbs determines how far you can see.
That makes sense. What I'm saying on top of this is that water molecules.
Well, the Glob claims it's an Earth curve. That is the reason.
I didn't. Well, sorry, what?
The Glob contention is that the limitation of our vision is the Earth curving.
That is one of the limitations. Yeah.
Well, it seems to be the only limitation because we have observations, like I mentioned, 275 miles.
But that's not like you can see.
That's miles of Earth curve, dude. That's miles of drop, bro. Not feet, miles.
Yeah, but I mean that just sounds right. Like if the Earth is curved 300 miles, should usually make it difficult to see things. But when things are really tall on one side, if you're tall on another side, you could, right?
Yeah, we understand that, but you can do the calculation to figure out how much the drop should be, right? How much something should drop down based upon any distance.
But you have to take into account the oblique spheroid. Like if this is at
the difference. That's a non-argument, right? Because I'll tell you why. The difference in the difference in the polar radius and the equatorial radius is 11 miles.
Really?
Yes, it's 11 miles. So if you did what's the difference in drop? It's something like in the 1,000th millimeter. Drop from eye level, right? So the general formula is, 8 inches, 7.98 inches per mile squared in with the mean radius. But if you take the polar and equatorial radius, the difference between those, the drop would be something like 7.97 inches per mile squared.
Yeah, this is making sense with what I know about tides, but it's not. I really gotta see that article. Yeah.
What do you know about tides?
I know about the spinning of Earth and the oblique spheroid connection to it.
Okay.
The small number does reflect that, which means me thinking that it would be bigger must have just been hocus from my mind.
No, according to the Globe, there's a polar and equatorial radius, and the difference is 11 miles.
Yeah.
So if you're talking about how much something drops down going in one direction, north south versus east west, it's imperceptible and probably immeasurable.
I would assume it would be measurable, but probably negligible. Yeah, I think your point stands. I can see
I mean, I don't know how you're going to measure freaking, fucking difference of 10 feet at 300 miles.
LiDAR is a great way. That's the way.
At 300 miles, LiDAR don't work.
Yeah, you can't do it on continental shelves, but you can do it with. You can sometimes do it, but it's like not accurate because tectonic plates kind of shift here and there.
So
you can do it off of the shelves.
So here, since you brought up LiDAR, you brought up refraction. Okay, so they tested refraction. They did a bunch of LiDAR measurements to quantify refraction, right, on a landslide. And what they measured was the maximum amount of refraction that they measured was, because the units into Europe, they use MGON. So 4 MGON equals 0.0037 degrees, or 27 degrees. So this was the max value that they measured. And they're measuring the deflection angle, right? So what they measured was, you have something out in the distance. How much is it moved up or down? What is that angle? And the maximum angle they measured was 0.0027 degrees. Now, if you extrapolate this out to like 25 miles, that's 0.2 of a foot. But at 25 miles, it drops supposed to be 420 feet. So moving it up 0.2 of a foot don't really help.
Yeah, I can see it's negligible.
Yeah, so like the laser test that we show you, they're not close. They're off from the Glob prediction by 2 orders of magnitude.
Mm-hmm.
So they shoot a laser 25 miles, and it goes from 10 feet to 4 feet. But the Globe says that laser is supposed to be 420 feet in the air. That's a 2 order of magnitude difference.
The thing that I'm seeing is that if you follow the Earth's model and point the laser at where the target should be, it will be blocked. But if you aim it over the water molecules have a carrying effect. I have to do more research
Wow.
into carrying effects, and I really want to see
water molecules carry light beams. This is the first time I've ever heard this.
Well, I mean, we had the PhD cosmologist say that light was skipping across the water like a rock. We had that guy.
Ooh, that could also help its effect. Yeah, if it's
going to be here's how it works. Water skips like a stone, dude.
Yeah,
not like a stone.
The light hits the water, bounces up in the air. Dude, let me tell you how this works. Light hits the water, bounces up in the air. Gravity pulls it back down to the water.
Okay, that's how he thought.
Is that how it works?
No, that's not how it works. Dude, who thought that? A cosmologist?
PhD in cosmology.
Because you know that gravity affects light, but not like that. Jesus.
I just made it up, you dumbass.
Oh, I thought that was a person's belief that we were talking about.
He didn't say gravity pulled it back down, but he said that their light was skipping like a stone across the water.
Oh,
you can actually listen to him.
Crazy.
If you go on my YouTube channel, I have an excerpt of that section of our discussion.
What, like you recorded the discussion?
Yeah, just like we're recording this one.
Ooh, okay, hold on. Let me get on YouTube here.
If you go into videos, right in the search, it will search my videos. You type in cosmologist, it'll pull up the video.
Oh, there's like a link to your channel?
Probably my profile. But we stream to 24/7 Flat Earth Discord. That's where we stream to. That's where this is going.
So it is on YouTube though, right?
Yeah.
What's the channel name so I can know where to search cosmologist?
The channel name that you're on right now is 24/7 Flat Earth Discord. My channel is named Indio 77 single line.
NDO77, huh?
Indio 007, INDIO 007.
Gotcha.
Just click my profile, I think, with my YouTube channel.
Yeah, that's definitely you. Cosmologist.
That's an excerpt. I'm sure the whole video, the whole audio. This discussion was, I don't know, like 4 years ago now, 5 years ago now, quite a while ago. He's a cosmologist at the University of Brighton. That's what he said, but you're not going to hear that in the excerpt.
Professor Stick kicks his own ass, like Flat Earth Professor? No. I'm trying to. I looked up cosmologist, and it's not really popping up on your channel. NASA can't get their story.
Hold on, I'll find the link, bro. I'll find it.
Thank you. Yeah, maybe. I mean, he'll do two possible things. He'll shed light on a lie by showing how stupid he is, or he'll shine light on how light can be carried. So either one of those would be good for me.
Not that he's lying. It's that people, they're so sure it's a globe, they have to cope in some way with the measurements, right? So like I told you, it's off by 2 more orders of magnitude. It's way outside of like imprecision or uncertainty, right? The only way you should see the laser is if you're on top of a 42-story building.
Well, it depends on how the physics are going to work with volatile water. I mean, the fact that it was done in nighttime, like with low heat, also kind of points towards your point because there'd be less volatility of the water. But it still depends on how volatile it needs to be, you know.
Well, according to terrestrial refraction is not like an unknown thing. It exists to some degree, but there's no model that makes predictions which are accurate. And they have tested it. And the only thing, oh yeah.
Oh, I mean, I guess weather is hard like that, man. Like if they could figure that out, weather would be much more accurate.
Well, yeah. If you think about it for a second, right? How would you be able to quantify how much refraction there is? You would need to know the humidity, the temperature, along the line of sight, the gradient, the amount of.
Use a lot of like big number measurements. They use.
Right. Well, yeah. You would need to know all the meteorological conditions to make a prediction. But if you could actually make that prediction, right, and say, hey, here's all the meteorological factors. That building's 10 miles away. It's 100 feet high. I'm at 10 feet. The Glob says it should appear here in the image, or I should see this much if there's this much refraction, right? You'd be able to make that prediction. But you would also be able to reverse it. You'd also be able to snap the photograph, right? Reverse the equations and spit out the weather that day. Obviously, that's not possible. The only way you would be able to predict weather that way is if you photograph rain or snow.
Yeah, we can get cool information though, like spectroscopy and all that.
Well, that's going to work terrestrially anyway. Mm-hmm. The point is that there's lots of models, and if you looked into the academic literature for terrestrial refraction and quantifying it, it's just they go out, they study it, and then their conclusion is, well, the weather's too fucked up, our model's wrong. It just can't make accurate predictions. Period.
Mm-hmm. I don't think exactly terrestrial refraction is what I'm thinking of though, because it seems that terrestrial refraction is like atmosphere. I'm talking about just above lakes or in high humidity, right?
Well, they've tested over a bunch of different surfaces. They don't just I would say it's well studied and still unquantified, and that's what it says in the literature.
Do you think what I'm talking about is like a subpart of terrestrial refraction?
Yeah, I'll give you, there's one that's like, it's called, I think the title is Modeling Terrestrial Refraction Using Reciprocal Zenith Angles. And then in that particular paper, they go over the previous literature where people did it over lots of different surfaces, right? So some people did it over grass, some people did it over water, some people did it over ice, some people did it over, like they did it. And the purpose of them posting in the paper was to get the bounds, right? That like, okay, if you do it over grass, you'll get positive and negative values of like plus. When I say positive and negative values, so what they do is they have a model where they say the ray of light, they compare it to what they claim the radius of the Earth is, right? So they say, hey, the radius of this ray was 20 times the radius of the Earth. So if you had a ray of light and you shot and it moved into a circle, right, then that radius of that circle would be 20 times the radius of the Earth. So over grass or something like that, over grass, I'll just give you an example over grass, because grass has decomposing matter, right? It gives off a lot of CO2. And CO2 has a higher refractive index than oxygen and nitrogen. So when they do these measurements over grass, they'll get extreme values like plus 20.
There's a lot of CO2 around plants, really?
Yeah.
It's crazy because I make oxygen, but I guess they have to be around carbon.
Right? I'm not talking like grass in your lawn. I'm talking like grassland, right? So in between the grass plants, there's decaying matter, right? There's decaying.
Right. And that's how we live. Like grass wouldn't be there without the carbon dioxide. So.
Yeah, exactly. So close to the ground, you have carbon dioxide, right? You can actually go onto it's called the EM Toolbox, where you can look up refractive indexes in the variables you enter. If you want to know the refractive index of air, right? The inputs are temperature, pressure, humidity, CO2 percentage.
Really?
That's how much it matters.
Like a greenhouse gas, like full term? Is it just always CO2?
Well, CO2 is the same refractive index of water. Might even be higher than water. Yeah. So air is almost the same as vacuum, right? And even changes in temperature, the change in the refractive index is like in the 5th or 6th decimal place. So it's not even, it's so minute. But like when you have it like, 1.3 or 1.4 as opposed to 1.00034 versus 0.0037, that's a little difference, right? So
gotcha.
When you have a difference between air, which is like 1.0034 and 1.3, that's a giant difference, and you're going to get a severe amount of refraction, right? Because refraction is caused by the difference in the refractive index. It's not caused by the absolute value, right? So it's the differences. It's a relative refractive index. And that's why we say, hey, dude, the differences in air, even if you have you have to have like crazy extreme temperature gradients, like 30-degree temperature difference in a foot.
Definitely, if we're looking at that.
Well, that's not really a physical I mean, have you ever experienced a 30-degree temperature difference in a foot?
Well, no, because it's always like a flow of energy. Unless you have like something really, really hot, and the in between them is like that difference.
Well, that's very funny that you mentioned that, because only one person that studied refraction, that's what their model was. It was called, he tried to model refraction. If you go through all the literature, they all pretty much use this one, like a spherically symmetric atmosphere with a vertical gradient, blah, blah, blah. This guy actually modeled it as what he called a sensible heat flux, meaning he tried to model what the refraction was by the flow of air based upon the convection of the different temperatures.
Yeah.
Wasn't that the one that you showed that had pockets of like different temperatures, like within the air, like throughout the system? Like,
yeah, that's one of them. Yeah, yeah.
Sure.
Yeah, but we're like way into the weeds, right?
That's how almost everything works, is that homogeny, because there's billions and trillions of particles.
Look, yeah, so the point is they use this super simplified model that don't exist in reality, and it can't actually make any predictions. They could have used, like I said, a spherically symmetric atmosphere, and then like the U.S. standard atmosphere, which is also a model, right? And they go, well, in these abstract models and these idealized conditions, this is possible. Well, okay, that's cool, but you need to show it experimentally. Regardless, you can come up with a model of anything. The models have to be validated by experiment, or it's not science. It's just theoretical.
I mean, I don't think the model is a truth statement. I don't think the model is trying to say that it's right. Like, I think that model that the Earth is a perfect sphere was just something that it was a logical conclusion to make after the belief that the Earth was a sphere was there. So they're like, okay, well, let's calculate how physics would work on a sphere now.
Yeah, but then
it's a truth statement.
Creanix, if that's true, then you need to tell NASA to take down all their images of the Earth being a perfect sphere. How about that?
Well, for them it is true, and they don't have to state it.
Well, they have images of it. They're telling everybody else. They're showing these images to everybody who thinks it's a perfect sphere. What are we going to do with that?
Well, from my understanding,
thought that was weird.
From my understanding, all those images are usually photoshopped from different angles.
No, but yeah, outside of that, dude, like they're presenting the Earth as a sphere, perfect, like a blue marble, and you're telling us that it's not a perfect sphere according to you, even though you think it's still a globe.
Well, NASA knows it's not a perfect sphere. NASA uses oblique spheroid calculation corrections in a lot of their articles.
But that's not what they're showing you. They're the images over a perfect sphere. So how is an oblique spheroid and a perfect sphere running in the same?
Like Indio said, it's a negligible difference with the polar radius and the equatorial radius. So with that in mind, it's probably negligible at a larger scale.
Well, I mean, yeah, but the blue marble, right, which they claim is a film photograph, they have a digitized image, and there should be one extra pixel on the equatorial radius and the polar radius, and the pixel count's identical all the way around.
That's interesting. I didn't know that. But still, even if that's true, it might be that it's just so far away that pixel difference is negligible.
Well, I mean, they use film.
Really?
So.
Sounds like you want to have your cake and eat it too.
I mean, it's all extremely photoshopped.
Like, really?
It's lumpy when it's convenient, and it's smooth when it's not, or vice versa.
So you become an apologist, Creanix?
I don't exactly know what that means, but I still believe that the Earth is a sphere, not a perfect one.
You're doing whatever it takes. It's like a sorry to put it this way, like a shithouse lawyer trying to do damage control. You're trying to do the best you can with whatever information is presented, even though it's contradictory, so that you can save face. You're trying to salvage as much as you can.
You're not wrong about what I'm doing, but you're wrong about my intention. It's not to save face. I believe that you guys will respect me.
Not you. I'm talking about so that the image of the idea that the globe exists will still be intact in some form.
Oh, that's not saving face, but I get what you mean. Yeah, I don't want to just sacrifice a possible perspective.
Well, why not? Okay, in other words, there's something a little bit deeper than what we've been discussing. There's the idea that maybe something in your psyche is holding you to this. Perhaps a profound experience when you were a young person, looking at some image of, like, I don't know, the cosmos, or something started this trail down this path that you're holding on to. It's like we're hearing you say what you're saying, but I think there's something a little bit deeper, like you're holding on to some experience, like an experience occurred, and it was like it moved you, and so that you don't want to let that go.
What I'm holding on to, it wouldn't exactly be one experience, but it is kind of like my self-identity when growing up, and what was fleshed out was my like love for the science.
Here we go, dude.
Exactly. See, and this is what we say all the time, Creanix. Go ahead, Indio.
I was going to say, give him a cookie, dude. He's like an honest Glober. He actually has some.
Yeah. No, but I'm saying, like, a lot of people don't realize this. You've identified that you do have like some identity with the cosmos and the Earth being a globe. All of that means something to you, and like not really, like you're not really investing in it, but you do think of yourself as a person that's standing on a globe in the vacuum of space, amongst other globes out there. But that's how you perceive your worldview. You don't really have a need to change that. So that's why you're doing what you're doing with the arguments. I get it. I know why, but it's like there's a sense of like what I'm giving you is like there's nobody at the end of all of this, like, gonna give you the attaboy kind of speech. Like, good thing, man. You stood up for what's right. Like, nobody's there, dude. Basically, you're doing it because of whatever experience you had back then. It created this, like, I don't know, like this identity, as you put it. But then you're wanting to cling to that, and it's like you don't have to, bro. You could just, at some point you could just let it go. It doesn't have to be today or end this conversation, because it might be a little bit prideful to kind of just do it right now. But at some point you could just let it go, not really hold on to it anymore. Just not like Santa Claus. It doesn't have it was maybe meaningful to you when you were a kid, but doesn't mean anything now.
I can agree that it's not practical to use in day-to-day life. I think it only comes out when I'm talking about these subjects, because I want to have at least a little bit of a side on the fence. I still, with everything I know that it connects the other perspective, I would have to de-ravel a lot of it in order to make the flat Earth make sense.
I mean, I get it, but I just want to let other people, like, I have to put it out there because it's true what you said. And kudos for being honest, but a lot of people don't realize that's all it is. Go ahead.
What would you need to unravel? Like things like, how do they predict eclipses? How do they predict when the sun rises?
No,
sunset?
I've done experiments in a class at college where we looked at like blinking of stars to see like a planet go by because it was supposed to, because our teacher was really into that stuff. I sat in astrology classes high as hell with my friend, looking at where constellations are in the sky, and we figured out a lot of fun stuff, like looking at stars, and we learned about the North Star moving. There's just so many things about so many subjects appeal to the globe Earth. How could you? So much.
None of that has anything to do with the globe. Nothing you said.
Exactly. The constellations themselves
astronomer just fine, dude.
The constellations themselves being the same shape as they always have been debunks your globe.
They're not.
And being in the same place in the sky over geographic positions debunks your globe.
But what about the spectroscopy we use to figure out like how far away something is using Einstein's equations?
You think it's that simple? Do you really think it's that simple?
Someone standing on the shoulders of many giants.
What is spectroscopy?
The actual technique is what I'm talking about. The technique.
Yeah, what is it?
Well, you need a very powerful machine. Is mostly the technique.
Okay. Yeah, but you make a measurement.
They launch light. You want me to explain spectroscopy, right?
I don't need to explain it. I know a lot about it. I don't think you know a lot about it.
That's what I was. Yeah, I thought it was a test question.
Well, do you know what Doppler line broadening is?
The Doppler effect I know of.
Doppler line broadening and how it applies to spectroscopy.
No.
See, it's not like people just say the word spectroscopy and that's how they sell it to you, but it's not that simple in practice. It's way more complicated than they make it out to be. Way more.
They launch large distances, I'm sure. Yeah.
Well, even to the sun.
That's a large distance to me.
Well,
anything outside atmosphere is pretty large.
It isn't going to get any better than that, right?
Well,
it isn't going to get any easier to the sun in the model, right? Like that's like the easiest one.
There's still ways around it though, because you can have like multiple sensors. You can also cross-reference different data.
The thing is, well, not with spectroscopy. So they're taking a spectrograph and they're drawing conclusions about the spectra.
Not with one machine. If you have multiple machines doing different types of spectroscopy, and you also have them triangulated around the globe, then you can get a lot more accurate distances.
More accurate how?
Well, just like you triangulate anything. If you have one depth of perception,
they're reading. Do you know what spectroscopy is? They're reading absorption lines.
Yeah.
Yeah. So that has nothing to do with any type of triangulation, dude. It doesn't tell you any distance. It tells you the composition.
Yeah, but like I said, if you apply the Einstein's equations to it, you can get distance. And using 3, then it does improve.
It's not that simple, bro. What I'm trying to tell you is it's not that simple. They make some assumptions about the internal process of a star, because a lot of these spectral lines are shifted, or they're too wide, or they're fuzzy, or there's other problems, and they have to have a theory to basically take a spectrograph and say, okay, these are basically like filters. Okay, think of it as a filter. Oh, there's Doppler line broadening. Well, how do we get rid of it out of the spectrograph? We'll apply this filter to it. Okay, there's this. How do we? But these aren't actual physical filters. These are like they're just equations.
Yeah, I will say I'm taking organic chemistry and learning about magnetic spectroscopy, and it's the same. It's like if you just did it plain raw data, you get just a bunch of lines. It's much less intuitive for us to even understand what's going on. So they will broaden lines and create equations that let them only see parts of the possible resonances and not others. And then they'll make them broadened lines. So you can get like graphs that just have a line there, line there, line there, even though it was a bunch of frequency before.
Well,
I think it's normal that we.
Yeah, great. But the point is that it's all theory laden. It's not just a straightforward measurement that they're doing. It's theory laden.
Yeah, no,
with a bunch of assumptions about how it all works out there, a place they've never been.
Agreed. I don't think it's just theory. I don't think it's just that. I think there's like some generational improvements, with collective consciousness and all that.
Or it's like, you said building on the shoulders of giants, right?
Yeah.
Yeah. You can build on the shoulders of giants and continue their mistakes forever and ever.
Yes, but the reason they're giants is because they had good prediction models. Maybe not for that field, but
I don't think that's a standard.
Is it not? I think validity is predictability and what's the other word? The word to repeat.
No, because whenever their predictions go wrong, they say they discovered something and give themselves Nobel Prizes.
Well, they take it away too. They take some of them away when they find out better things. It's a momentum.
I don't know if they're stripped of a Nobel Prize, but they should have been.
Not a Nobel Prize. Like this guy found Uranus through math, right? Or sorry, Neptune.
That's a fucking myth, dude.
Even so, he got a Nobel Prize for that. And then he found another object, and then he found Pluto. And he was saying, yeah, this is a planet. I'm discovering planets. But then they had to take away that status from him, and they actually discredited him after in his career for just kind of going on a power-hungry kind of, I just need to discover everything and call it a planet thing.
Well, that's another thing that's more complicated. So using math to discover Uranus had to contradict other math that they were using for all the other planets. Something called the Titus-Bode law, which gives you the distance of all the planets where all the planets should be. Each, if it's here, they follow a relationship. So Uranus and Neptune don't fit within this law, but this law was derived from Newton, right?
Yeah, that's actually how we found their math. Realized that the law was wrong because Uranus was moving a little bit off of it every once in a while.
Yeah, but the law shouldn't have been wrong. That's the problem. Saying they used math, they had to discard. They had to discard other math.
Yeah, always. Yeah, because math is incomplete and not fully correct. I mean, one water droplet plus one water droplet equals one water droplet, right?
This is the funny thing about math is that nobody ever thinks about all the math that was discarded as wrong. They only think about the math that's right, and that's what I'm trying to bring out, right? So,
but they do think about the math that's discarded as wrong if it's a building block.
That's what I said. They never admit they're wrong, and when they discovered that they're wrong, they say they discovered something, and they give themselves Nobel Prizes. That's exactly what you just
does happen. But I'm talking about in the mechanisms of math, you'll see how do we solve a polynomial, right? And then they'll find new equations.
Say I have a mathematical theory, and it turns out something in it doesn't match prediction, and I go, look, I discovered an anomaly. Give me a Nobel Prize instead of just saying my model was wrong.
Well, you don't get a Nobel Prize until usually something actually doesn't prove but verifies it.
How about dark matter? Let's use that as an example. Why does dark matter?
Dark matter is a funny, weird one.
Why does it exist as a concept? Why does it exist as a concept?
Yeah.
Why did they need it?
It exists because there was a 4 magnitude difference in not magnitude but multiplied difference in gravity that we should have, or 4 to 6, I think. There's so much more gravity was required for the elliptical galaxies to have the movement they did and not unravel it onto themselves.
So instead of saying we don't see any matter and this model must be wrong and doesn't actually work, why didn't they just do that? Why did they say we discovered dark matter?
It's like Newton physics works on scales on Earth usually. It doesn't actually work in large scales, and that's why it's technically wrong. The equations we have now are also technically wrong. They don't conclude everything. That's why we build them. That's how I see it.
You're very you should be in PR for the scientific community, dude. Instead of just saying the model. No, but seriously, if you got hired for a job and they said, "Hey, we want this," and then you there was something wrong with it, they wouldn't be like, "Oh man, you made a discovery."
No, I would. If there's something wrong with it, I have to have funding in order for me to go towards it on my own or with a team. And the company can sometimes fund that stuff if it's practical for them. It's all about debate nowadays.
Well, you know what an ad hoc hypothesis is?
No, what's that?
So ad hoc hypothesis is something that's added to a theory or a hypothesis to prevent it from being falsified.
Ooh, that's always bad in the scientific community. They probably
use it, and that's what dark matter is. And I'm gonna segue back to the topic. That's what refraction is. It is an ad hoc hypothesis.
Dark matter is falsifiable, though.
How is it falsifiable?
Because dark matter is an assumption that matter exists in the places we don't see it. We also have different theories that are
How would you falsify it?
Debated all the time. Well, you would falsify it by discovering the reason there's extra gravity there. You can find that there's a problem in the equations. You can find that there's something else leaking gravity that doesn't exist in this plane.
The reason there's extra gravity. Why is there got to be extra gravity?
Well, there is extra gravity. That's the measurement. That's the not.
No. You don't see gravity, right? So what they see is the radial velocity of galaxies. That the things at the end of the arm should be flying away, but instead of flying away, they're not flying away. And since their theory says gravity is what holds galaxies together, they have to say there was an extra mass or extra gravity. Well, there could be other physical phenomenon other than gravity that's keeping them there, right?
You would think,
doesn't even have to be gravity.
When you get into the quantizing of stuff, gravity is just a mass field almost. Like, so anything with
you
mass
understand what I'm saying?
interacts
It
with the
doesn't have to
gravitational.
be that. It doesn't have to be that. It could be anything.
It doesn't have to be that.
Maybe there's a voltage potential, right?
Well, that would be a charge. Charges interact with voltages, so it would have to be something that's affecting masses that are uncharged. Is the problem? They're not that charged.
What? What is not charged?
A lot of it is charged, but it's not. I mean, I don't know. Maybe you're right. Maybe that is possible with all the charge stuff.
I'm just saying
it
doesn't.
usually a little charged here and
Okay,
there, especially
so the point I'm trying to make is the theory that galaxies are held together by this that conform this model of gravity was false. And instead of allowing it to be falsified, they decided they were going to create an ad hoc hypothesis to prevent that. When they actually didn't know and still don't know why their model don't work.
Yeah, I think that's always been true for the scientific field. I don't think that's abnormal. I don't think it's an ad hoc hypothesis, so to say. I don't think maybe the media side of science uses it as an ad hoc hypothesis, or maybe a lot of dumb people who don't understand science.
There's no evidence for dark matter.
Absolutely, but there's also not a true statement in it. It is an imperfect model that is known to not be fully true. Like everyone in the field who is trying to improve it knows how flawed it is.
You stick around. Dude, stick around and listen to the people that come into this chat, and we'll see. Well, just anybody that comes in here, some science nerd, some sophomore and fucking taking physics courses, they'll swear up and down this shit's true.
That's so. I know. I hate that, bro. I think they're dumb. I was like them in like middle school, but then I realized from teachers telling me that like the more you know, the less you know. Like the more we discover, the more we know we don't understand. The more different ways you see how to.
Yeah, but the confidence from these guys when they come in here is like you wouldn't even believe it. For the years that we've been doing this, I mean, we've talked to all types, right? But especially the academic types. They like the guy.
Oh yeah.
I think India was showing the guy that said that light skips over the surface of water, like up and down, like a stone skipping. Like that was something we all were just like in awe about. Like, how can you propose being a cosmologist coming from this vantage point and then say that's the way light travels over the surface? That's how it reaches its target distance.
Yeah, a lot of people who learn stuff, they don't learn how to explain the stuff they learn. And I always think that's kind of dumb. It's like, if you can't explain it, why do you fully believe it, right? Like.
So, I mean, we're left with people that are like just ill-equipped to even propose any idea, especially scientific communicators. I mean, those guys seem to be the ones who undo a lot of what people would have an idea of the Earth being a globe and with gravity and all things like that, like what the Earth looks like. And you're like Neil deGrasse Tyson, he was speaking at a conference and he was saying that, the Felix Baumgartner Red Bull space jump, he was jumping from a specific altitude, which is 120,000 feet, somewhere around there. And he said from his gondola, he did that jump from edge of space. He's like, I don't mind him calling it that, but it's not from the edge of space because, from that height, you don't see the curve of the Earth. That stuff is flat. And he did it with his hand, like his motion with his hand.
Yeah. I've seen him explain.
What? We get it. No, he thinks the Earth's a globe. Yeah, I mean, we do understand that. Like that's where he's coming from. But the fact of the matter still stands that what he said, according to what people think, is opposite. So we use him as a hostile witness. We use him so that people can realize when they start saying that they see curvature from a mountaintop or from an airplane window, that's not the case. You're not able to see curvature from altitude. So we have a contradiction in these explanations, according to some of the zealots. That's what we call them. People who have like this. Strong belief that the Earth is a globe. They won't let these points go, or at least to somebody with I would say, let it go to somebody at a higher standard. Like these guys are scientific communicators. At least they know.
I disrespect people who hold to like conclusions from science so hardly because it's like my father has a great phrase, which is the facts change, and that's always been true. Like.
Well, no, but I'm saying is that like the people that hold to these standards, they're adamantly defending something that they're at the end of the day we wouldn't be able to like.
Lack of knowledge.
You can't. Okay, so the way the pecking order goes, right, is that since you guys are the ones receiving the information and you're just the average Joe, those who have reached certain heights in academia, those would be the pillars of knowledge that you appeal to. Now you don't and you can't say that you know what's happening because they're the ones giving you the knowledge of what's happening. So you can't therefore usurp your knowledge over theirs because they're the ones that achieve some pinnacle of like knowledge and in the realm of like scientism or whatever. I don't care how you think about it.
No, you can. Just because there is a validity structure in place doesn't mean that I can't have something I have validified and then
there's a standard is what I'm saying. Like they have drawn the line of the sand. We have already said academia agrees with me, not me but them, Like, academia agrees with me, and like when I speak for academia, this is what I'm saying, and so all of academia is backing them and not you. So you can come up with any theory you like, but it's not going to be according to what the mainstream narrative should be.
I disrespect those people. If I'm put in that kind of case, I go, well, no, scientific community likes this kind of banter. Are you against the scientific method? Are you against inquiry? Like, what's up with
you? So this is what I'm bringing up to you, man. So we've heard in those realms they call it settled science. I don't know if you've heard of those words and those terms being put that way.
I hate that term. Okay,
well, I mean, it exists, so they're using it like a weapon. So in other words, they're shutting down the conversation of those who would inquire further about the topic. Therefore, you can't anymore say that.
Exactly. I would disrespect the hell out of that. Yeah.
So, what we're doing here flies in the face of that, of course. But even for those within their community, they would say, well, we have these parameters, and you can go no farther than you can work within the parameters, but nowhere out of bounds. Because if you say something outside of these things that we already have settled, then it's just a no-go, right? So you don't get the funding, you don't get to play around with the
just
club.
Because someone else settled it doesn't mean you've settled it.
But what do you got to work with? So you can be a rogue out here on the internet saying what you want. It's still not going to be the narrative and what's being spoken over to millions of people in education system. So that's what I'm saying. You can say whatever you want.
I think what I'm saying is reflected in every education system I've been in because I've had good role model teachers. These teachers who taught math and science, they know how to explain it in a way that they're saying this isn't just truth. This is what we did because it was practical. This is how we discovered that we can achieve that, but we still didn't understand that. Even when I'm learning organic chemistry in college, my teacher goes, we don't know why. We try to mask it by saying this, but we still don't actually know. That's how the best way to teach.
That's interesting. That's interesting that he even said that to you. Like, what does that mean to you, though?
Well, it means that we don't know. And I think that's the worst part of these people who use science as a coping mechanism. It's the same type of people who use aliens as a coping mechanism. When you don't know why something's happening, you're supposed to just say, I don't know. That's what allows for curiosity. That's what allows for you to push forward and stuff. But instead, they just go, nah, it's aliens, or nah, this is explained by the scientific professor.
I'd have to think about
these
that.
guys, they use science as a buzzword. Like the people that come in here and front us,
I hate it.
Science is a buzzword. They think the word science is synonymous with truth. And they go, science proved it. They'll say things like science proved it. Well, and I'll tell them, science doesn't prove things. And they're like, who said that? Science. Like, science says they don't.
Einstein said that. Yeah.
But, and the thing is, too, man, what we are saying is that scientific inquiry is a beautiful thing, man. Like discovering new things of the physical world. Like, we're all about that. And the thing is, when we hear people saying things that are just completely outside of the realm of the physical world, and it's more of like theoretical, then it becomes like, oh, wait a minute, like why are we going down this path? Like, so in this room, right, empiricism really is like a standard, but we're not just going to let go of the fact that we can see the physical world and test and do all these things, and you're telling me to let all that go and think about this idea as if it were like automatically true. Like, we can't do that. So I can't just beg the question with you and think of the Earth as a globe if it's never been presented in the physical realm that way. So you get what I mean? So you have to at least come with the goods. Give me something. What can I work with? If it's just going to be mathematical applications and things that we're going to, we'll think about it in this way. Look, just in the form of math, an oblate spheroid, this model that you're presenting to you, a geoid model, whatever it is. Like, that doesn't really help because it's not, we got to put that model against something else. That way we can know that the physical world actually identifies as what you're claiming it is. Otherwise, what do we got to work with? I mean, it's what I'm saying.
Yeah, I mean, I agree with you. I always like to say this, and it's very hard for people to grasp usually. But you only can conclude rightfully and justly if you have a goal. So if their goal is to disprove you, that justifies for them that they can conclude that these things are true. But them in a different setting, they actually will be like, oh, we don't know, because that's a different setting, right?
Bro, I gotta say, you know what? And because you said that, there could be explanations as to what gravity is, right? And all these kind of ways to think about it.
Not a perfect one, yeah.
But when you get them right down to it, do we know what gravity is? Gravity, what is it? Gravity, what it is? Well, we don't know. And that was Neil deGrasse Tyson as a quote when he was being asked by one of these, radio hosts, and they asked him that question. And it's kind of it's weird when you hear him say that the way he did, because he meant we all understood what he meant. He doesn't understand it fundamentally, like what it actually is.
Yeah.
But how many of people that come in here will stand by that kind of hey, you know what? This is the best we got, but we actually don't really know. We don't hear that, dude. It's opposite of that. It's no, we know what it is.
I think they misrepresent science, but they're zealots. What can we say, right? Christian zealots do not represent Christianity. I hate that, bro. That's why I said most people in the Flat Earth chat are usually smarter than the average person, because you guys actually are empiricists. I do know this.
Yeah, it's the kind of world we live in right now where it's more of nowadays what we deal with is just the identity crisis. But basically what I told you about. People that identify strongly, they have some kind of spiritual experience, that's what I would name it as. Spiritual experience about having an interaction in their young age where something grabbed a hold of them like really strong. Like there was a, who knows, like a video of like the planets doing something, or some teacher was speaking charismatically, or something happened where it jolted their spirit to be like, whoa, like and then all of a sudden they carry that up into their adulthood. They don't question it anymore because everybody agrees with that. So it becomes like a tradition that's been handed down, and without any question, it shouldn't get questioned, right? So that's what we're doing in this chat. We're questioning that very thing that you've been told. And why not look into it, right? But it's
what I think is interesting is to question it is like the basis of science. So for them to not question it is to go against science. Science isn't easy. Science isn't just something you get accustomed to when you grow older. It's something you have to put that effort towards and follow role models to get to, like a good grasp of it. Like you can be an empiricist without science. They're not interchangeable. Empiricism is the basis of valid truth because it is experience. But the scientific method is to take that valid truth and through scrutiny turn it into something practical of a model and a tool. Okay. Any other truth statements? Yeah, I think that person doesn't know what science is.
Okay.
Like you can only get truth when you have a goal. If your goal is to understand a system, then you must conclude things about the system. But if your goal is to understand the absolute truth, you're not going to conclude anything about the system. You're going to see what you understand, take that data, and move forward the best you can.
That's an interesting articulation.
Good. Should I set him up?
You're going for the jugular?
No. Is there any scientific evidence for a globe?
So evidence is different than proof, as we know. I'd say there's evidence towards it being flat and a globe. I'd say there's a lot more of it being towards a globe.
Scientific evidence. Is there scientific evidence?
There is scientific evidence towards both. Scientific evidence, the only requirements to me, it's not about validity. It's about having gone through the validity testing.
Not having a good story. Not about being valid. Not having a cool story.
No, it's about practicality. Mm-hmm. The validity is how well it works.
So the shape of the Earth is the shape of the Earth is not a scientific question at all. It's a geometric question.
Yeah, it's like, what science do you need to measure a beach ball? That's the question simplified.
So, science in general deals with natural phenomena, right? You figure out the cause and effect relationships.
Their momentum, yeah, as to build.
Yeah, so like there is no cause and effect relationship with like what is the figure of the Earth. Right? So it's actually not even a scientific question. That's part of the propaganda. Like the I don't know what you would call it, selling point propaganda. So they tell you, oh, science figured out the Earth's a globe, but that's not even a coherent freaking statement, because that question is not a scientific question. It can't be answered by science. It can only be answered by like measurement. Just like, say I wanted to know what the mean height of freaking pine trees are. Mm-hmm. Okay, I would just measure a bunch of pine trees. The act of measuring all those pine trees is not science. It's just measuring something.
Empiricist, yeah. But however, science would be multiple people can measure those palm trees.
No, yeah, but measurement is a different category. So in other words, the question was malformed for a purpose. It was to get you to identify what science deals with and what it doesn't deal with. So it being malformed, given to you, you should have been able to, understanding what science is, being able to categorize it and say, wait a minute, science? No, science doesn't deal with the measurement of things. Science deals with the how-why questions, as into like what you were describing earlier. So
yeah, I would answer that by saying science has things to do with it, but not the truth. It doesn't have to do with the truth of it. The truth of the matter is not science's domain. But science's domain is the practical uses of different.
Yeah, I get what you're saying, but in the kind of way that we're wanting you to realize that when things are being used of like the phrasing, the wording, right? So if something has to deal with science, it's very specific. It's a certain category. It's not this other category where you measure things. You get what? So it's a parsing out of what science is and then putting it in a specific category, not in the one that you want to put it in just because you like the word science. It has a specific. It has a specific connotation, is what I'm saying. So if it does mean something, if it does mean something, then it should be categorized as a specific thing. It's useful for a specific type of inquiry, not for just everything. So you can't just broadly label science for measuring things. That's not science.
No, but science. When I say science, I mean scientific method being applied to something, right? And
yeah, so do we.
Yeah,
it's experiment.
When I think of the scientific method, it must include measurements.
Well, I mean, it can, but it doesn't have to. It can, but it doesn't have to.
Are there examples of them not measuring anything in any science?
Well, it doesn't have to be quantified.
Yeah, you're not looking for the quantification. You want to cause the operation. You want to cause you want to cause a reaction. So if you just like give you an example, like for example, dry wood. Like obviously it burns, right? But you want to find out what causes the reaction for combustion to happen of why dry wood would burn. So you're gonna look for things without like trying to quantify. You're just looking for what things make dry wood burn. right? So
But
you
just
throw some.
because you come to a conclusion doesn't mean you are correct nor valid.
Well, but here's the thing, though. You're gonna throw some sand on it. I mean, you might throw some water on it. That doesn't cause a reaction. You're gonna try to do whatever it takes, right? Then all of a sudden you get to the place where maybe you light a match or something, and you see fire happening. You put it to the dry wood, and the dry wood starts to burn. So what happens is, like, you see it happening right there and then. You see the reaction between dry wood. You use
Empiricism to
fire.
create a model.
Yeah,
But that's not
what I'm
science
saying
because
is, hold on a minute, dude. Like, what I'm saying is, you see something happen in nature, right? There's a natural phenomenon of dry wood burning. You see something, a tree being burned up. You see a
trial and
tree
error,
being, yeah, you see a tree. Hold on, dude. You see a tree being burned up in the woods because it got struck by lightning or whatever. So you saw something happen, and you're like, I wonder what caused that. I know I saw lightning, but I want to know why that wood is burning. So you want to know. So you're gonna start doing things to cause the same reaction. And so you're going to use methods, right? Different things. And you say, I tried all these other things. This one thing is what works. And so you're not like measuring like, okay, I'm only going to put, 5/8 of this thing in here, or you know what I mean? Like 3/4 in there. Like you're just going to.
That's not science at the end of the day.
Wait a minute, dude. You're just trying to cause a reaction. That's all you're doing. You're using an independent variable to cause a reaction in the dependent variable. So you're not.
An experiment. Yeah.
Yeah, I know, but you said it's not, and I'm telling you it is.
No, it is an experiment. It's not science.
Well,
it doesn't follow
what
the
do you
scientific
mean?
method.
What do you mean it's not?
It follows experimental methods, but the scientific method includes you must do background research, and you must publish the results for other people to look at so they can repeat that.
Yeah, it could be testable, repeatable. But what I'm saying is when
it has to be tested and repeated.
When the researcher's actually doing the inquiry as to like what's happening, you have to formulate a hypothesis to test it, right? I wonder how we're going to do a test. So in a controlled environment, you're going to figure out how you're going to manipulate this independent variable to cause a reaction to make the dependent variable change. In order for you to do that,
experimental method, yeah, but that's not the scientific
method. It's following the scientific method because you want to see a naturally occurring phenomena. When you see something happen in nature, you want to know why that's happening. So you want to cause a reaction in the dependent variable. In order to do that, you're going to have to change the independent variable. You're going to have to manipulate that. So what I'm telling you is that you don't have to like measure things. You can just try different things. So there's no measuring there that happens. You just.
So, if I may speak uninterrupted for a second, because I fully understand what you're saying. I'm saying, in order for it to be science, it must have background research and be repeatable and be presented.
That's incorrect. I told you about my vacuum chamber before, and you went, blah, 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 well, and I didn't need to get Flat Earth Ranger over my house to do it with him.
Yeah, that's correct.
When you have this system that must have all these different parts, I'm saying some parts are not found when you're just doing that experiment. And the scientific field has to include all these different research. So the reason that measurement, I feel, is a requirement in true science is because you must be able to repeat it and others must confirm through repeating the same thing.
Yeah, I know, but you're calling it true science doesn't change the fact that it's still science. Like it's not.
It does change. It does, but it's an experiment.
It doesn't need to be quantified. It doesn't need to be quantified. Okay.
Okay. What's the independent variable
quantification
that won't be quantified?
You can just X causes Y. That's it.
Okay. What's the independent variable though? In
germs cause disease, right? We can figure that out without
disease.
Yeah. We can figure that out without
germs?
Yeah, germ theory, right? Germ theory don't have any quantifications.
Germ theory has quantifications. Yes, they do.
But it's not required.
It is so that they know what they're talking about. They have qualitative descriptions of different types of germs, and then they have
qualitative, right?
And then they have quantitative categorical distinctions.
But what I'm saying is quantification isn't necessary. It's not necessary. Faraday didn't quantify the law of induction.
I mean, he did.
No, he didn't. None of his original experiments have any quantifications in it.
Yeah, but when he published it, it had quantifications because it had.
No, someone else did that.
Oh, well, then they're the ones who applied
science. That's ex post facto.
And more science.
So the point here is that you can follow the scientific method without quantifying things. You can figure out the cause and effect relationship without quantifying it.
You
Now,
understand where I'm coming
in
from?
modern
Like, I think
practice,
you need
hold on.
it to
In modern
communicate it
practice,
with.
you would quantify. You would do a bunch of trials, right? And then you would give it a p-value to figure out whether that that effect, that cause and effect relation of that experiment is greater than chance. That's just
That's only
modern practice. Yeah, but that's just modern practice. That has nothing to do with whether it's a valid experiment or not. Still following the scientific method, whether you quantify it or not. Now, you could say this isn't rigorous enough for me to believe in, but that's just that's just a personal thing. It has nothing to do with whether the experiments follow the scientific method. Now, what we're talking about is when you say Earth is flat, Earth's a globe, Earth's concave, Earth's a freaking pineapple, right? Now, think about your house, right? There's lots of shapes in your house of different things. You could take a tape measure, run out through your house, measure everything, and you wouldn't call yourself a scientist because you know the freaking height and depth of your cabinets, would you? If you knew that your table's a circle or a square, you wouldn't say, "Hey, I just did some science."
Yeah, no, I would not. I would say I
Yeah.
did
So
some
when
measurements.
we measure the Earth and say, "Hey, the Earth is this or Earth is that," we're not doing any science. We're just measuring its form.
Well, science has a lot to do with measuring.
You have to Creanix. You have to concede, bro. This is a valid point.
That
This
is a
is a
very
very
valid
valid
point, but I don't think he's taking into account certain fields of science that
Well,
absolutely
we're
have
not.
to do with measurement.
Yeah, but the form of the Earth being what it is not a method of science, scientific inquiry. It's just measuring it. You're trying to figure out what it is. So, what is question? A how wide
Well,
question would be what science would be dealing with.
But science deals with when we ask, how can we measure that?
Yes, yes.
Yeah. So it is a
But we're
method
not.
and a tool of
Not how.
use,
Not how
right?
can we measure it? Now, what we're dealing with is what is the Earth. And so, if it's something that you can put in a category of like, well,
Science
it's
can't answer that. Yeah.
like if it's an oblate spheroid, or if it's a cube, or if it's a pyramid, or some other kind of 3D shape that you're trying to put it in, then that's just you're using a method to figure out how to measure. You're just trying to measure the thing.
I mean, you're not wrong, and I don't think science will tell us what the Earth is. But when we ask, how do we measure this, we use scientific methods and tools to help us measure things.
My God, it's just going to keep doubling down.
Let's say we want to find the coastline surface area of a country, and this is practical because it's a way that they
So, what are you trying to find the cause of?
Yeah,
you're trying to find the cause of coastlines or coastline length.
I'm trying to find. I'm curious. So this would be me asking a question. How can I get a standardized measurement for the coastline? So now I do background research. I understand the complications of doing finding the length of a coastline.
Apply scientific method to it, dude.
Area? Do we go off of tide? Do we go off of?
Yeah, just apply scientific method to it.
Hypothesis. Yeah.
What are you going to do with the scientific method here?
Yeah, what's the cause and effect of coastlines measurement?
Why is this a question?
Yeah,
because
you see, it's
trying
not
to argue. Science is measuring.
It's not a scientific endeavor, just like was said. Like measuring coastline, it has nothing to do with science.
Yeah, everybody's been telling you this.
A scientific method, it must include the cosine thing.
Oh my God!
Yeah, you don't have a cause and effect relationship with.
He planted his flag on this hill. I think this is the hill he wants to die on. I guess.
The thing is, this is what's blowing my mind is that he was repudiating this hill like 5 minutes ago. That's why I brought it up, because I knew when it came down to Brett, when you brought up science in the globe, people would try to defend it, even though he was. Don't take this personally. You were saying people use science all wrong in lots of situations, and they believe science is, all these things that it's not. But now when I mention science in the globe, that mind virus, you planted your flag on the hill, dude, and you're going to die on it, even though it seems like a pedantic argument, but it's really not.
Yeah, you went cattywampus, dude, when he told you that. So now we're trying to figure out why. I know why. You even said why. You're identifying with the Earth being a globe. So you have some sort of psychological tie into this thing. So you're kind of invested, man, whether you think about it or not. You try to sound a bit unbiased, like you don't care either way. But it sounds like what we're hearing is different. Like you really are, like,
well, the thing
you're
that
trying
made
to find your way around this, man. There's really no way.
I'm hearing you.
Okay,
The
well,
reason
I
why
mean,
I started going that way was actually my connection with the scientific method. I think it's being misapplied if you think that's all the scientific method is. That's
Yeah,
all. I don't care if
you
it has
have
to
a
do with
mis-
globe or
you
flat
have a
Earth.
you have a fundamental misunderstanding of the scientific method.
Okay, explain to me why you can get rid of a certain step in the method.
Okay, so I'm going to present you an example. In front of me on the table, I have a cube, a sphere or a ball, and a triangle. What is the cause of those shapes?
Depends on the material.
So you think there's a cause
got
of
it
those shapes? What caused those shapes? So you think that's a scientific endeavor?
And you think that those shapes are a natural phenomenon?
Just because there's cause, it makes it a scientific endeavor.
Yeah, it has to have a cause and effect. So you're looking at a naturally occurring phenomenon in nature. You don't find those shapes in nature, for one. When we're talking about Earth, it's a geometric question, period. It's not a scientific endeavor because there's not a cause and effect with a geometric shape. If we're just measuring the surface of Earth, that's a geometric endeavor. A measurement is all that's required. You don't need cause and effect. You don't need an experiment to measure something. You just measure it.
But I think we all understand that in the globe theory, we don't have the full measurement. Like there's trees. We don't include all the trees.
Oh my God. Okay, we're not talking about trees, bro. We're talking about the measurement of the surface, like legitimately over water. Like drop over distance over water is mostly what we talk about.
Right. But that's fine if you apply science to it. That's great. Just applying
How
an
do you
experimental
don't
method.
apply science to it? You don't do that.
Okay, let's walk through the scientific method. What would we want to know what the Earth is, what its form is? What's our independent and dependent variables?
So we would have to translate stuff into them, but
what does that mean? Like we want to know what's the independent variable and what's the dependent variable? What's the control variable? What's the null hypothesis? Like what are all these things? These are all
measure
hold on. These are all components of the scientific method. All of them.
They don't have to be. They're not always part of it.
They have to be.
I mean, in what situation would they not be part of it?
In situations where you're not comparing results. But you can do it with comparing results and finding the curvature of the Earth.
Comparing results is after the fact. Do you get that?
Yes, that's results of the entire thing. I'm talking
after
about results
the fact.
of specific.
So we're not talking about after the fact.
It's part of a research paper.
India's asking you.
If you have two different groups, they'll have two different results. Those are the results I'm talking about comparing. If you have to
compare after the experiment is done. Yeah, that's besides the point. We can talk about comparing results afterwards.
Part of the what? No. Like if you're doing an experiment, the only time you need to have the dependent and independent factors are when you're comparing two different groups, so you can see the difference.
True.
You're trying to figure out the relationship between the variables.
Independent means it doesn't change based off of the environment that you put it in.
No.
And the only way to have an independent variable is for two different groups to share that independent variable.
No, that's wrong.
That's what I was taught.
X causes Y. The independent variable is X. The dependent variable is Y. So, for example, we observe a natural phenomenon. That would be the effect, the observation of something happening. That would be our dependent variable. What causes that is the independent variable, right?
But the independent variable that causes the dependent variable can also be dependent.
Oh my God!
It could be. Okay, it could be, but that's why you're supposed to identify confounding variables and control them, right? Those would be control variables.
To have multiple groups so that you can compare them to understand that they don't change.
You can control them experimentally by just holding them so they don't change, right? So if they don't change and you manipulate the independent variable and the effect changes, you know the cause of the effect, as long as you've identified all confounding variables.
Yeah, which you never can, but if you have enough of them, yeah.
Well, I mean, obviously not. That would take fucking omnibrain, right?
Even in NASA labs, they can't. Yeah, they've admitted it themselves.
So we got away from the point there. So Indio asked you a pretty poignant question. So in the question of what Earth is, let's start from the beginning. What is your phenomenon that you're observing?
Well, I mean, we can just go to. He already admitted that measuring items in your house and their shapes and sizes wasn't science. How, when we use the exact identical methodology, tape measures, like rulers, shit like that, that somehow it's different because it's the Earth?
Well, because when you're doing it in your house, you aren't using the tools and methods that required science to create.
What?
What the hell does that mean?
It means that you did not need a standardized anything to build upon the idea that you
rulers are standardized.
Yeah, meters are standardized, miles standardized.
That's not created by science, though. And they're not standardized by science.
So what? What does that even mean? Created by science? Is there like some magic science genie creating things?
Yeah, so tell us the standard. Tell us the standard of measure that science created. Go ahead.
What? No, I said it doesn't.
Yeah, that's what you said.
It created Newtons.
You said a measuring. You said a measuring.
That's just a unit.
A measuring standard that was created by science. So we want the measuring standard or method that was created by science.
Spectroscopy.
Is that a standard? Is that a standard of measurement?
Jesus Christ, man! Did you really just say that?
Thing that has standardized units like frequency and all this.
Is that how you measure things with microscopy?
He's throwing shit at the wall. He has no clue what scientific method is. He's trying really hard to fit his geometric claim of globe into the scientific category. He doesn't have any clue about any of this stuff. It's totally obvious.
Doesn't. So
You've been telling him over and over, you're going to test the cause of a natural phenomenon. That's what the scientific method is for. Then he starts saying, oh, that's the experimental method. It's the same fucking thing. Experiment is the test of science. That is the scientific method.
I think the scientific method must include.
Yeah, now we're going to get what he thinks.
Background.
He's just going to ignore what it actually is and tell you.
Can you do science without experiment?
No.
Okay, then we just gave you the experiment, which you can't take out of the scientific method. We just gave you the scientific methodology for doing an experiment.
Right.
Yeah. So it applies not just to the experiment, it applies to the scientific method as a whole. Nowhere in there can measurement of the Earth fit.
No, measurement of the Earth and what it is and what it actually looks like is not science's job. No, I've already conceded that. But when it comes to finding out those measurements, you do use science.
How?
In what way?
Well, I mean, the laser, it was invented by, understanding and building on blocks through.
You haven't told us. You haven't told us what method that is.
A laser
scientific method.
The problem is he has to call this science. That's where he's coming from.
No, it's what I was taught. The scientific method is applying all of these steps in scrutinous order.
Scrutinous order. Jesus Christ.
Okay, could we do the same experiment without a laser and just use a mirror? Are you going to claim mirrors are invented by scientists?
I would say that you can't create. I mean, no. Some of the mirrors.
Because these experiments have been done with a mirror.
Mirrors have existed for a long time. They don't take much science.
Yeah, and these tests, these long distance tests, have been done with mirrors.
Okay, yeah, then that would
no lasers. So the device is what makes it science or not? The device, the measurement device itself.
Yeah,
like that seems
that is
really
one of the factors. Yes, yeah. But in this case, if you
the measurement device.
I mean, that's what I said, isn't it? Like that's
what would one measurement device versus another? How does that change it into science? What qualities of the device?
The science is a manufacturer
to understand and build on.
That doesn't make any sense. We want to know about the device itself. Okay,
yeah, but
I have a mirror. I have a laser. Why is the laser science and the mirror is not? Or vice versa?
Because the understanding of it comes from the momentum of the collective consciousness using the method.
Okay, I'm not touching that, dude.
Word salad.
That's not word salad. It's word salad to not use the scientific.
Yeah, you don't know what it is. Still, even when told what it is with an open book test, you failed. You don't know what science or the scientific method is. You think it's something other than what it actually is.
What is it actually?
It's actually a method.
Right.
Testing the cause of a natural phenomenon.
Yeah, naturally occurring phenomenon.
The cause, dude.
The natural phenomenon.
Yeah, that's what it's for.
Not man-made phenomenon, not mechanical phenomenon, naturally occurring phenomenon, like
I thought
out
it
in
was
nature.
to find the mechanism so that you could get better predictability.
Mechanism. So, what are you studying? You're studying the mechanism, or you're studying a
I'm
cause and
studying
effect?
mechanisms of stuff mostly.
A man-made mechanical device.
No, mechanism is the concrete step-by-step cause and effect relationship that creates the outcome.
Oh my god, it's never going to get to any specifics. So what in particular was the scientific method used for in any of what you're talking about?
Yes, please, somebody stop the
Scientific method
painful.
was used to describe how chemical reactions occur.
Okay, well, we're talking specifically on the topic, though.
Yeah, science isn't about descriptions either.
The coast stability, like we used mathematics to help with the coastline.
Okay, that's mathematics. That's a coastline. We're talking about whether the Earth is a globe or not. Whereas science used in any claim that you have. Okay, there we go.
It better.
How?
Because we applied understandings that helped us get more accurate results.
Okay, you're just talking like vague. Yeah, so
it doesn't mean it's correct to apply the understandings or that the understandings of science is correct. My point is there are cases that people use science to help with measurement. That's really the claim.
Where? Which one? Which one?
When, where, and how? What method?
I mean, lasers.
Yeah, be specific.
Is one. Anything
lasers. Okay, how was the scientific method used for lasers? Yeah, okay, don't gish gallop, dude. Lasers.
He's barely listening.
Scientific method was used how for lasers? What was the natural observed phenomenon when the scientific method was applied to lasers for measuring shit?
They would do an experiment with lasers.
No, that experiment will come after the natural observed phenomenon,
and
dude.
then people would be able
step
to
one. Start with step Start with step one, natural observed phenomenon.
Yeah, for the creation of lasers.
They naturally observed that light existed. In some sense, it was different than things.
Okay, naturally occurring phenomenon. Light existed. It's different than some things. Okay, suppose cause for light exists.
Now we go, okay,
different than some
that light is reflecting off of that surface. Why? Why do I see the sun when I'm looking away from the sun? Right?
Science doesn't answer why questions.
So a mirror then? That's going to be your independent variable? A mirror reflecting sunlight?
Well, that will be part of the experiment that starts the building blocks. I then understand that it's some type of reflective surface. I then come up with equations to help me predict where it has to be in order for me to see the sun and at what angle. And then I produce those results. And then other people go, well, those are inaccurate results. I'm going to build upon them and make your math more clean. I'm going to...
Mr. Magoo's sophistry hour. It's just painful.
Yeah, how did they come upon a laser through their scientific experiment?
Well,
what was
once
the experiment?
They understood through background research, anyone who has a question of like,
what was the experiment? What was
background research?
We need the experiment.
Your hypothesis or your question can just be, what would happen if I launched a bunch of like flashlights together? What would happen?
What the fuck?
What was the cause and effect of? What was the cause and effect of flashlights all put together?
The cause was the resonance within the flashlight's light as well as the light itself, and the effect was increased frequency of the rays coming from the flashlights.
What the fuck? Well, let me ask you a question. Do all questions that can be asked, can it be figured out scientifically?
No, you can never figure anything out.
Okay, so what you're saying can't be figured out with science.
Correct. Can't be figured out with measurement, and it can't be figured out with experiment.
Because you're talking about things that are man-made. We know how they work because man made them.
We didn't know how they interacted with each other when you put them together.
That's not science.
Yeah, that's called engineering.
It is a science.
We did trial and error, right?
That doesn't mean you figure it out. But
no, it's test and
observation. We did trial and error. Trial and error.
You
guys don't want to acknowledge that almost everything.
Method. Trial and error.
No,
is a big
it
part.
isn't.
Yes, it is.
Trial and
If
error
you
has
look up
nothing to
any
do with the
diagram
scientific method.
of the scientific method, it has arrows that make loops, because if it does not align with your results, you try again, construct a new hypothesis, test it with a new experiment. And if the
This is a
working,
different
no,
trial
you
and
go
error.
back to test with an experiment.
Okay,
These are trial and errors.
This isn't the
embedded
trial
within
and
it.
error I'm talking about. The trial and error I'm
Oh,
talking
okay.
about is engineering, right? So you have a bunch of equations, and you say, "Hey, we're going to manufacture this part and see it because we want to do this." Then you
can apply the
manufacture the
scientific
part, and
method
then
to
you
that.
test it. And then
Yeah, the
in the
trial and
test,
error will be
it
part
doesn't
of
work
it.
exactly as you say, so you change how you manufacture the part. That's trial and error.
Yeah, and that's part of the scientific method. Yeah.
None of that.
Exactly
That's
what's happening.
engineering. None of that
Just
is a
because it
scientific
exists
method.
within, actually, engineering uses a scientific method like that all the time.
No, it doesn't, because scientific
Yes,
method
it
only
does,
deals with natural
different
phenomena.
materials. Yeah, the
Scientific.
phenomenon of different materials' physical properties and how it affects with
Okay, be
electricity.
specific. Okay, be specific about the phenomenon observed in nature that the experiment was based on, and who actually
Okay,
did it. Give us something real world that someone actually did. Don't just blather
He
something off
can't
the
hear
top
you
of your
because he's
phone,
talking
dude.
through you.
And don't just make something up on the fly. Give us a specific real world example. Something somebody actually did.
What I just thought of is human-based. So
You're going to just go again with stuff that you're making up here on the fly.
No, I'm not. I'm thinking of stuff that is actually known.
You're talking like in vague generalities, right? There's no cowbell here.
Flashlights are the cowbell.
Yeah, you got nothing. You're making stuff up, dude.
You guys made up someone seeing a tree get hit by lightning,
Oh
right?
no, you guys.
Someone. I'm trying, bro. I'm gonna look for. There's different examples that
Trees
definitely
getting hit
occur.
by lightning now proves that you live on a ball. That's awesome.
Said that. That's crazy.
Wait, so what shape do we live on?
We can't get to that because he's desperate to call it science.
No. I'm just curious on y'all's opinions. I don't give a fuck about his opinions on shit.
We don't live on a shape.
What do we live on?
Earth.
Yeah, but like, what is it?
Space is fake, so it's not a shape.
It's a what?
Not a shape. Space is fake. You don't fly around in space.
No, yeah, but like, what's the shape?
No, yeah. There's no shape.
What's the shape of the universe?
Expanding in all directions.
Relative
If you had a balloon that's expanding, it's still a balloon shape. So what's the shape of the universe?
I don't
again?
think he asked me what it was
flat.
doing. I think he asked what the shape of the
relative to
universe is.
concave and convex, the universe's shape is flat. It's one of the reasons we assume that there was a really big and fast expansion at the Big Bang.
Where's the edge of the flat universe?
For it. Huh?
First of all,
I don't know if we know much about the edge.
All
We
right,
can only see
facts.
as far as our different electromagnetic, things let us.
But you're positive there is an edge, right?
Follow-up
I'm not positive
question.
there is an edge.
Follow-up question. Are we prompts?
Huh?
What does he want to be?
Follow-up question. Are we prompts?
I don't think so. We can be, if you try hard enough.
I've met some prompts before.
Hey, CB,
one more question.
About you, I'm like, man, if you were here, you'd be cooking the stew with the soundboard.
Facts. Wait, one more question for the flat universe guy. Can you draw the shape flat and then post it in the chat?
Oh yeah, I want to see that
What,
too.
the shape of the universe?
Well, you said the shape is flat, so can you draw the shape flat for us and then post it in the chat?
I won't draw it myself, but I can give you our best rendition of a two-dimensional 3D flat plane.
No. It's just keep it real simple. Open up your notes app or MS Pen or something, and just take your pen and draw the shape flat, and then we'll take a look.
I think we both know what that would look like. It'd be a line.
Nope.
That would be called a line.
Yeah, it would be a line.
Do we need to go back to what shapes are?
He asked you to draw a line. He asked you to draw a flat.
So sometimes in class they're talking about a line, and
you're
they
talking
say
about
a flat. Yeah.
Okay. Yeah. Sure. Yeah. Yeah.
Really? Yeah. That you've heard that happen before.
No, that just works with what I meant by flat. It means like I
So
think.
if I draw a curved line, I can call it a curved flat.
I don't know. I
Yeah.
just learned.
Teacher says draw a curved flat. I've had that happen before.
Oh, you guys are making that up.
Do we have to teach you what shapes are? Radwin, get your triangles
No,
out.
if I draw something flat, it'll just be a line.
That's called a line. That's not a shape.
Hey, do you know
I
what a
wasn't asked to draw
triangle
a
is?
shape. You want me to draw the universe?
No. You did. You said, "What's the shape?" And we said, "Well, what's the shape of the universe?" And you said, "Flat."
I didn't just answer flat. I said
Should we just rip the
relative
Band-Aid
to
off?
convex or
Let's just rip
concave,
the
it's
Band-Aid
flat.
off. Flat's not a
The
shape,
space can
dude.
either be concave or it can be convex. And in the universe's case, it's flat.
That's not a shape, brother.
That's fine. Okay, I guess I misanswered the question.
We can reveal to you how it's not a shape if you were just to take your
I
pen
was
and
just
draw
talking
it.
about it's geometric shapes. Like not
Yes.
exactly a shape or
Flat
a
is not a
standardized
geometric
shape.
shape, dude. This is crazy, bro.
Is
what's happening, Heretic? What's happening to the Globetards, dude? They're getting more and more retarded over the time.
What's happening
bro.
is you don't listen and understand. I'm not getting retarded.
I don't understand. You don't know what
In fact, you
shapes
don't
are.
listen.
Yeah.
We heard you.
You're here telling
No, you
us that a
didn't.
line
You
is
think
called
I
a
don't know
flat.
what shapes are?
So the
You think
teacher
I'm
says
going to
draw.
line a flat?
Take it.
What are
MS
these?
Paint.
What are these assumptions about me? They're
MS
crazy.
Paint. Go to your notes app and draw the shape called flat.
I would just draw a line.
That's not. That's not a geometric shape, dude.
Yeah, flat isn't a shape, right? Why would I draw a shape if you're asking me to draw something that's not a shape?
Well, when we asked you what's the shape of the universe, you said it was flat.
Yeah, I said in relative to convex or concave, it would be flat. And obviously, I conceded that I misanswered the question then because you were looking for an actual shape.
No, you were looking for the shape because you asked what's the shape of the Earth.
No, you were asking for the shape because you asked what's the shape
Is
of the
this
universe.
Bro?
You did ask what the shape of the universe.
I'm helping you reveal how retarded your question is, basically.
What was my question?
What is the shape of the Earth?
That was my question. When?
This is live recorded, dude. Should we play it back for you?
Then. Please.
Yeah. All right, we're gonna play it back, and we're just gonna pop you on mute. After that. Yeah. All right. Cool. How do you forget what you just said? How am I remembering your own words for you?
I don't know why you're putting words in my mouth. That is weird.
Oh, it's live recorded, but all right. Give me 1 second.
Hey guys, it's Max.
What's up, Max? What's up, like, dude? Are you trying to gaslight us or something? You asked what the shape of the Earth is.
Did I?
I'm pretty sure you did.
Yeah.
I saw somebody else talking.
I thought it was someone else. I don't.
He absolutely did. I just want to see if something's going to happen once he hears this
It
recording.
actually wasn't him, it was me. And I asked that question and I got a complete non-answer. And that's
Yeah.
okay.
I said he wants you to draw a flat. Remember that he wants you to draw the shape flat so that we can describe it to you.
That's what he said.
After I was asked what the shape of the universe was.
Draw that for us. You said it's flat. Draw it in the shape of flat.
I told you exactly
I think
what I
the
would
universe
draw.
is a sphere
draw
too.
line.
Like if the start of the universe was a big ass explosion, explosions don't travel on a fucking 2D plane.
Well,
they expand in all directions.
No, you got
it's flat.
You got bendy space time flattening everything out.
I ain't never seen no bendy space time in my
I
life.
said it's flat.
Yeah, me neither.
Relative to convex or concave. This is probably out of like the scope of what we're talking about. Anyway.
Relativeness to flat, not you don't base flat off that. Flat is flat. You start
we're
with
looking
flat,
at the universe for non-Euclidean geometry, and that would be convex or concave geometry. They were looking for it throughout the space, and they only found Euclidean geometry.
Stop reading chatbot.
It's not a chatbot. I just remember the word.
Maybe he
Euclidean
is a
and non-Euclidean.
chatbot. Maybe that's the problem.
I was chatbots before chatbots, and I think they usurped me, bro. I hate it. They usurped me from my stance.
What?
He's feeding our audio right into Chat GPT.
No, I'm not. Can I do that?
We've had people do that.
That's awesome.
We had a guy that was turning everybody's speech into text in real time.
That's so cool.
He accidentally shared his screen and showed it.
What chat would you use that in? If you went into one of the chats on this server, which one would you want to use that in the most?
Oh, none.
We're not going to tell you how to do the cool shit.
Tactics.
Dude, I
Yeah,
don't
you
want
don't
no
need to pick
permanent
up any
record.
dickhead tactics. You don't need to do that.
I don't do the dickhead
We're not going to
tactics, don't
tell
worry,
you
but
how
I
to
can
do dumb
appreciate
shit. Do you
someone else doing that.
understand that? We're not going to tell
I
you how to do
understand
it.
that you don't trust me, yes, and that's fair not to trust me.
Oh, look, this is a
I
crazy
will tell you
anti-flat
I wouldn't do
earther,
anything
globe
with it, but
apologist
yeah.
that was trying to like refute flat Earth. He was in here for months, and kept failing. I actually think he teaches at a university, but because what he was doing, he was taking people talking, and he was turning that into text so that he could go over the text and look for holes in our argument so he could come back with a better one.
That's so sad, bro.
And the only reason it was discovered is because he shared his screen, and then when I clicked on it, I saw my name pop up when I was talking, and the words I was saying was text that was appearing on his screen in real time.
That's insane, bro. That's a great catch, bro. Imagine you didn't catch him doing that. You just didn't know why he was being weird for so long.
Yeah, I mean,
that's so crazy.
Yeah,
that's such a cool story.
Wait, did Creanix say that flat was a shape, or was that someone else?
I didn't say flat was a shape.
Well, I don't know why you responded when the other guy chimed in. Did he leave? The other guy left anyway.
Well, he's saying flat isn't a shape. Just let him do his,
Yeah, it's fine.
But
When the
let's
other
say
guy
he
spoke up
misspoke.
and responded to him. He then Creanix responded for some weird reason. But all right.
I thought it was me he was talking about because we did go over the draw flat. I said it would be a line and stuff like that. I was just saying if you're telling me to tell you the shape of the universe, I misunderstood that as describing the shape rather than giving the shape.
Well, the question was for the other guy who spoke up and said, "What shape do we live on?" So I was asking him, but then you responded. So.
Oh, I didn't know that. It doesn't clock to me, but if you say so.
I mean, it's weird. We haven't talked about flat Earth in a long time now. I mean, honestly, we haven't.
That's true.
So how could you definitively prove the Earth is a globe or not, or flat or not?
Well, to definitively prove either of those, you would have to go away from the Earth and see it in a different
view. It really. I don't know why you guys say that. I really don't. I don't know why you people think I'll just look at it. Do you think like if you were like you're gonna do a peer reviewed paper and they're like, well, how did you figure out what that was? Like, I just looked at it. Do you think that would fly?
I thought it was implied that we use our eyes in a certain way.
Yeah, we do, but like
be able to
if you build, but if you build something, you can't figure out the shape of the pieces of the house by just eyeballing the pieces.
But I can see that the house is house shaped by seeing it from an outside.
Oh my god!
Well, that depends on the angle you look at it, right? So if you're directly above the house, it'll look like a square, right?
Yeah. What if it's a crooked house? What if it looks like a Doctor Who house where it's all crooked?
What you're saying is,
that's still house
if
shape.
I go up straight from the center, then it would have the same view if it was a sphere or flat, or a disc.
You're just stuck. You're stuck.
Well, dude, what I'm saying is that you couldn't tell just by simply looking at it. That would be very subjective.
Well, it depends on the shape. Like, if it can be different things, if there's different possibilities.
Well, what if you saw a big circle, right? And what if the Earth is a
that's what I just. Yeah.
Or
what if I saw a disc? What if I saw that there was a flat on top and I saw that there was like a thing coming? I don't know if it just extends off into infinity behind it. I can't tell, but I guess see it from a different angle, right? If I just add another angle, it'd be good.
So what if you're the radius away? Whatever circle you're looking at, what if you're the radius of that circle away? And you look at it from different angles. Guess what? It'll still look like a circle.
When I said that I was going to go away from the Earth, I meant far enough so that all of the Earth is within my field of view.
Yes. And if you're the radius value away of a circle, right, the distance, no matter where you are, the angle subtended by that circle, it's always the same. And it will always look like a circle from every angle.
I mean, yeah, I agree.
Okay. So it would be a disc, but you, because you're looking at a bunch of different angles, would reach the conclusion it's a globe.
Well, if it's a disc at a certain angle, it'll look like a line.
Yeah, I said radius distance away. Yeah, if you're looking at it edge on,
then
like,
it'll
is
just
that what
be,
you're
like,
planning
filling
on
my
doing?
vision.
Looking at it edge on?
Well, if it's, I gotta get different angles. I would hope that I can get at least 3 to see, dimensionally.
So you think it's possible to see an Earth disk?
If the Earth's a disc, then yes.
So we think Earth is a disk? Then is that right?
Not at all. I only brought up disc
Okay.
because I thought of the different, it can be a disc or a sphere if you go
Yeah,
up
but
from the center. And then he said a radius away, and I think that's supposed to be.
There's only one angle. You'd have to look at it edge on to see it. What was it? Every other angle other than the freaking basically zero angle, it would look like a sphere as long as you're the radius
Well,
distance
it would look
away.
like an oval sometimes,
as long as you're the radius distance away from the center. This is it. You could prove this.
If I'm a radius distance
hold
away.
on, dude. You could prove this, dude. There's a mathematical proof to this. You could prove that this is the case.
I believe you, but I'm not going a radius distance away. I'm trying to get further.
Okay. How do you know? How do you know you're further?
Because of the relative size in my vision.
Dude, that doesn't really
I
help
can experiment with both multiple different 3D printed shapes of possibilities of the Earth, and I can experiment
Where
on
does
how they
3D
would look.
printer come into this? Like, what the fuck?
Just a way to get shapes. You want me to find natural rocks that are a donut?
But what's the one you experience in reality? What's the only one you measure and experience in reality, though?
What do you mean between
The
a globe
the
and a
whole
disc?
point of this is that it's subjective. Everything you're saying is, I'll just look at it. It's subjective.
It would be from my perspective, yeah. But
Yeah, subjective.
To a scientific field for other people to check. But
Well,
it's
so
just
what?
for me
And then
to know,
you're
right?
gonna
It's not
pile up
it's not to
subjective
prove it to
experiences?
anyone but myself.
Okay, but you're just going to pile up subjective experiences that is going. But you can prove it to yourself. That's why I asked
that's what
you.
I'm saying.
Like, it was kind of loaded, but that's why I said, how could you prove it definitively? Going up high and looking at it does not prove it definitively.
Right. Oh, okay. I misunderstood.
It would prove it to you.
Yeah, you
but
can never
how
prove
we
it definitively.
well, you can. Well, you can because we have a true dichotomy, right? Either the surface of the Earth is curving, in which case it can't be a ball. You can eliminate ball by just measuring that one property. Its existence. It either exists or don't.
Wait, I don't think that's how true dichotomy works here.
Well, can you have a sphere that's flat?
You can have sphere that is flat at certain points.
No, you can't, dude.
How many flats make a sphere?
Zero. And at what point? Yeah, he said it. He said zero.
or
At what point do we identify this?
Yeah, zero.
Mental gymnastics. What the fuck?
Yeah, but in a flat plane, there's also zero flats.
Okay, so the
Because
property of a
in real
sphere is that
life-
it's equidistant from the center, right? So
real life-
no line can be equidistant from a single point.
No lines. I mean, maybe some.
A line, if you drew a line and a point, like every point on that line can't be equidistant from that freaking point, right? That is a property of a circle or a sphere in 3 dimensions, right? So this property is a dichotomy.
No, because it's not about if it's a sphere or not. It's about if there's curvature due to the fact it's something like a sphere.
Circular reasoning, then.
Yeah, so you use 6 words to say the same thing Indio just said.
Yeah, we can figure out sphere or flat just by measuring the surface. We only need to know the surface properties. That's the point I'm making. We don't need to do anything
But we need to know
convoluted.
every single surface's properties.
We need
But
to
even
measure,
if you
like,
have
okay, say if we measure
flats-
the water and the water's all connected and water shares the same property and we measure it flat and most of the surface of the Earth is water, then the Earth can't be a sphere because you can't have a 51% flat sphere, dude.
Yeah, but that's good deduction. But the things you assume to be true aren't true.
What am I assuming to be true?
That
What
the water has the same properties.
That water has connected bodies of water. You think they have different properties? That they curve some places, they're flattened in other places?
Yes.
Right back to square zero, it seems, from like 2 hours ago. He hasn't.
Yeah.
Yeah, what part of your experience tells you that water doesn't have the same
Part of
fundamental?
anything tells you that, dude.
Tectonic plates can tell you that.
Well, I
tectonic
mean,
plates have to do with water?
Wow.
No, they create ripples throughout the water that give it a
Okay.
curvature.
Hold on, let's
Until it
just end
settles
this shit
down.
because now
But
you're
then it's
going to
also
bed-like retardation. Does flat exist? Is anything flat?
No.
Anything? Nothing. Okay, then we
Nothing
just
is
end
flat.
this. Why are you even here if you don't think
Okay.
anything's flat whatsoever?
Exactly.
Because I thought we were talking about like a generalized shape.
Can't admit to anything being
You're the
flat.
one making the pedantic argument like there's waves, so it can't be flat, dude.
He said tectonic plates have ripples on top of the water. I think he's trying to say.
Earlier, Old Hall said something about the fish jumping out. Shut up! Earlier, Old Hall said something about the fish jumping out of the water, and he said that was curvature also. So he's clearly a dumbass.
No. The problem is he said that it's either curved or flat, and I was like, well, no, right? Like
That's a true dichotomy. That's a true
it's
dichotomy.
not a true dichotomy. Exactly, it's not. Is what I'm saying. And
What's the third option? What's the third option?
It's homogeneously different based on your location.
What?
The hell does that even mean?
It means that in some places it's flat, in some places it's convex, in some places it's concave, which is
So if
true.
I measure someplace flat, when I move, it's not flat anymore?
Well, if you're on the top of one mountain and you see a mountain away from you,
So he's talking about topography. This dumbass. Oh my god.
Yeah, topography.
Yeah.
Exactly.
Listen, dumbass. What if I'm at sea level?
If you're at sea level, even what's around you can change the shape. We're talking about the shape of the Earth. Are we also going to?
Yeah, I measure the water over water and measure.
And we're talking about the macroscopic shape. At the macroscopic level, flat or curved, dude.
Yeah, dude, I already explained this to you earlier, remember? I remember we had this exact discussion, and I said what we're talking about is Earth curvature, not the curve of a wave or some shit. You already agreed.
You absolutely did, Cyclone. Yes.
So we don't need to retread this tired attempt at a rebuttal to there being.
We actually never got a concession from him. That's why I'm retreading this, dude, because he's in like skipping rope, double dutching, doing mental gymnastics to avoid this. And that's why I went back to it. And it's just really, it's, very ironic that Cyclone, you come back right into the place you left at. And we're still.
I know, I'm feeling like a deja vu. I'm like, what the fuck is going on?
No, I'm feeling the same thing. I was trying to explain the reason I brought it
because
up.
Because it definitively answers the question. That's why we're on it.
Yeah, but there isn't a way to definitively define the question for more reasons than the thing that I just said about it being.
Okay, so if the surface of the entire Earth is flat, it can still be a sphere.
Well, depending on your scale and what you've defined flat as in your experiment, yeah.
He brings experiment into it again.
Depends what you mean. What the meaning of is, dude. You like Bill Clinton, it would be jealous.
Just saying words.
This isn't just saying words.
It's something weird.
When you're doing
You're
an
obviously
experiment,
not
you can make the
uneducated.
model work no matter what, as long as you use the right.
No, dude. Dude, listen to what he just said. If the entire surface of the Earth is flat, can it be a ball? He said yes, dude. You're not uneducated.
Well, I'm going from the
why you're
perspective of a
saying
human being, man. Like, if I'm a human being,
No,
I have
from the
decided that
perspective
the
of a
entire
human
Earth
being.
is flat wherever I measure.
No. He's saying if the surface of the Earth is flat, can it be a ball? He didn't say from your perspective if you see it as flat. He said if the surface of the Earth is
if
flat.
every surface of the Earth is flat, then it would not be a ball. That'd be right then.
Correct.
But we
Every
don't know
surface.
that. And even if you measure every surface, that doesn't mean that.
You're even trying to qualify that, but I get it. It's your called this.
Yeah, every surface. What if like 51% of the surfaces are flat? Is it still a ball?
Well, that wouldn't really. I'm trying to imagine what that looks like.
Yeah, you would have to imagine. Yeah, you would have to imagine.
Well,
yeah, we know you want to
you don't have
imagine.
to
That's
imagine.
what. That's what
Once
you've
you
been
imagine
doing.
it, if it's
That's
if
what you've
it's
been doing the whole time you've been here, Creanix, is imagine. So what if 71% of the Earth is flat? Can it still be a ball?
well, no, it wouldn't. There wouldn't be enough material that's bending.
Okay, welcome to flat Earth.
That doesn't mean I'm flat Earth. It just means
Yeah,
that
it
if
does.
everything's flat, it would be a ball.
71% is water. So yeah, it's flat. We measure it that way. We practically use it that way. Everyone does.
Just because you
I just want
measure
to
a
say,
surface as
despite
flat,
having
it depends on how you define flat. That's why I said what I said. It depends on how you define flat.
We have to redefine words because he's backed into a corner in the
Hold on,
earth.
You have to
We have to
define words
redefine words
because they don't
now.
mean anything without definition.
Chill. I was just about to give you a compliment. Say, so far you've been pretty chill. You've been respectful and polite, so we appreciate that. So let's give him some grace, guys. I mean, I've not heard the whole conversation, but let's give him some space. Obviously, there's some cocktails there that he's trying to work himself around. But yeah, I mean, still continue the conversation, but just keep in mind he's not being belligerent. So you can be chill.
His struggle is inside him. His struggle is inside himself, dude. Certainly.
Creanix, what was your rebuttal to that? Just because you measured what I couldn't hear.
So it was what I had said before, which is that it depends on how you define flat, and how you measure it. Because if I have a sphere and something is microscopic on it, and you define flat as this level thing in front of you, you created a thing that's like 5 meters long, it seeks level, right? You place it down and it is perfect, both corners touch the surface. You just have to get small enough for that to be true on a sphere. So if the globe was a sphere, even if you measure flat in different areas, it's not going to reflect the actual shape unless you get long enough. And
So you can't use your logic like he tried to do for you and realize that 71% of the world is water that measures flat and equate that to no flat surfaces on a globe. So the earth must be
at
flat.
long
You can't do
distances,
that.
it
You can't
doesn't
use
measure
that simple
flat.
logic.
Hold on. What we need to address here is the
What makes you
definition of flat, because that seems to be where he's getting confused potentially. Do you think flat can mean curved?
Yes, he said it. He said it.
At a certain perspective, they are not
Right.
distinguishable
So
from each
see,
other.
this is the problem. We're just gonna he's gonna completely not understand anything if he thinks flat can mean curved.
Yeah, like I said, we have to redefine words.
Yeah, well,
It's not
this is a
redefining.
problem. You keep saying from a certain perspective. We're not talking about looking at it. We're talking about measuring it. That's
Okay, well, if you
objective.
measure it, you get the
Also,
curve
when you're imagining,
Okay, why do you say that?
because of how nautical science works.
Because nautical science.
Nautical
That's how
science.
nautical
What
science
science?
works.
What science is that?
It's a new branch, right?
Science that led to inventions like the sextant.
like when you grab onto
Our
a
words
turtle,
just falling out
like
your
when you
mouth
grab
randomly.
onto a turtle and you let the turtle swim and you just glide along behind it. I think that's what he's talking about.
That nautical science.
Okay, so what does the sextant measure about the Earth?
Is it not? It does not. I don't know, but I thought.
Then why are you bringing it up?
You hold it up because
Yeah, you don't
it's a
know.
science that has
He
to do with.
doesn't know what
Like,
flat
it's
is.
kind of a faith.
That's a good
It's a faith
answer.
reasoning. It's that
It's
ships
just such a good
use
answer to hear, bro.
of the Earth
Nice to hear.
in
When you don't
their
know, just say, I
measurements
don't know.
and their units, right? I don't.
Yeah, you're digging yourself a hole.
You can't say
No,
I
it's
don't
fine,
know,
guys. It's fine, guys.
obviously.
It's fine to let him say, I don't know. That's a good response. If you don't know, you should say, I don't know. But then don't be like, but I do think, and then go on to argue again. Just be like, I'm
Yeah,
not
for
really
3
sure.
hours
It's
he
hard to
hasn't
keep
said
track.
I don't know
What
one
evidence
time
do you recommend?
for 3
That's
hours.
definitely not
Should I
true.
look
That
at?
is definitely a lie, or not a lie, but misremembering. I have said I don't know multiple times.
I don't know why you think
Well,
the
that's
sextant
good.
measures
That's good.
curvature. That's really what that's boggling my mind. Why do you think a sextant's measuring curvature of the Earth's surface?
I never claimed that.
Okay, you said it's curved over long distances. I said, how do you know that? I talked about objective measurements, right? We can measure the Earth, and it measures flat. And you're like, no, it measures curved. And I said, how do they do that? And you said with a sextant. So that implies
No, I did not say with a sextant. You said, "How do I know that?" And I said,
yeah.
because of nautical sciences. And someone said, "What is the nautical sciences?" And I said, "It's the stuff that led to inventions like the sextant and then we kept talking."
Who has measured Earth curve? Good. When, where, with what instrument? Yeah, with what instrument?
LiDAR's one.
They measured Earth curve with LiDAR.
Now, are you sure about that?
Are you really saying that?
Words are just slipping
We're
out,
talking
apparently.
about measuring, not definitively making it, right? They used LiDAR and that measured it.
Okay, how does LiDAR work?
I really want you to
LiDAR works a lot like you just bounce light, but it's more than that. It's a certain type
Yeah,
of.
you
Remember, I asked you for this measurement. I asked you for this earlier, and you didn't send anything. So, have you found something now, and it's LiDAR? Is that what you're saying, or are you just kind of
Something that
saying
does what? That measures the surface of the Earth?
That actually measures curvature surface?
Yeah, I sent that in.
LiDAR does not measure curvature, dude, at all.
It can, but it's not going to definitively tell you curvature.
No,
it can.
They don't even model it to measure curvature
Well,
at all.
when you get the entire mapping of the surface under the water, you're able to.
Yeah, what does that got to do with LiDAR? LiDAR don't work underwater.
LiDAR does work underwater.
LiDAR's infrared. Does not work underwater.
So he just doesn't know what he's talking about then?
LiDAR goes through heat. What are you talking about?
Yeah, it doesn't work underwater.
Water. It doesn't go through water. Water absorbs that wavelength.
Does it?
Yeah, it does.
So did we
infrared.
just establish that he doesn't know what he's talking about?
Now, you could say radar, but then you have another problem, or sonar. Then you have another problem because they have these things under the ocean called abyssal plains. Abyssal plain. Most of the ocean underneath the water is a giant plain.
Yeah, flat.
I mean, I'm seeing them using LiDAR to get coastal maps, to get like continental shelf readings of the entire surface under.
Yeah, I think you're mistaking LiDAR for another technology.
No, it's LiDAR. It's just
Okay,
a different type of LiDAR.
Are they measuring the ocean surface, or are they measuring underwater?
The surface under it.
Post it.
Yeah, I need to see that. Dude.
Hey, what's up, guys? Is the Earth still a pancake? Question of the day.
Never was, never will be.
Oh, so it's not flat. Good. Thank you.
Well, no, that's a false.
Yeah, he had to just say that, a drive-by.
Cope of the day.
Copium.
That was a quick cope. Actually, they measure it flatter than that.
Yep. Noah says that the abyssal plains are they're the flattest parts of Earth.
Trace found it. They use water penetrating green light to measure seafloor and river.
Yeah, you just copied that out from Drace.
No, this is what I was thinking of. I was imagining.
Yeah, but LiDAR is not green light, brother.
Diagram.
LiDAR is infrared.
No, it's not in this case. It's not always infrared.
LiDAR is always infrared. That's what LiDAR stands for. It's an acronym.
I don't know what you're talking about.
LiDAR is an acronym.
We know.
Yeah, I know it's an acronym, but it doesn't use infrared in the case of barometric LiDAR.
Yes, it does. You literally read it in my source. It uses a near-infrared laser to map the land. However, they have a specific type that used to try to map the sea floor. However, that doesn't show any curvature.
It does show the landscape of the sea floor, and if you can...
Yeah, which is a plateau, dumbass, or flat.
The continental shelves, yes, but not the sea floor.
The sea floor are mostly abyssal plains. What are you not getting about this?
Yeah, there's no curvature at the bottom there.
If it's a plane, if it's a long plane, then there would be, unless it's just so non-homogeneous.
Yeah, it's flat.
Yeah, if it's flat, then you would see the curvature using LiDAR.
Yeah, you don't see any curvature. It's just flat.
If it were flat, you would see the curvature? What, sir?
Well, like we've already established, it can seem flat and be curved at the same time.
Oh
No,
my
we
God!
did not
Here's
establish
this.
that.
Here's this flat can be curved at the
So
same time again.
now it's not
I mean,
measure
I think
curved,
that
it's
one I
just
believe
seems
in.
curved.
If you can, I feel like it's a lack of understanding of what I mean.
No, I'm going to get a clip of it. We understand perfectly. You think flat can be curved. You just said it.
Exactly. Yes.
Yeah, I'm going to
Yes,
get a clip
you
of
don't
it.
know what you're
We're going to
talking
share
about.
that through all of the. I'm going to clip it myself.
Can you
I just
explain
really
in
wanna
layman's
know.
terms how flat can be curved?
I have tried multiple times and I will again. It is perspective.
So it's not measurable, it's not real, it's just apparent.
No, it is measurable, but it depends on how far your data reaches.
So then can you show us the data that's actually measured it? That's what this whole conversation's been about.
Yeah, I've sent an article earlier.
Yeah, we're not talking about looking now. See, you're confusing projected perspective geometry with orthographic, absolute values, right? Not so. Like when we look at things, we only see things in relative angles. We can't tell distance or size, right? From
Well,
just
if you use
looking at
enough
things.
angles and you've created a context.
Well, you need a priori knowledge of size or distance.
Does
You need
touching
prior
it count?
knowledge.
If you can compare it to your own body size, touch it and then go away from it, does it count?
Well, yeah, because then you know a size, right? You know your own
Right.
body size.
I've touched
But we're
the
not
earth.
talking about looking at things, dude. We're not talking about looking at it and saying, does it look flat? Does it look curved? We're not talking about that.
Yeah, but it's
If I have a line of
negligibly
sight, right?
curved.
No, it's not
negligibly curved.
negligible. It's
That's what
not
I'm saying.
negligible.
It
It's
is a
8 inches
negligible
from a.
curve
It's not.
in
It's
certain
not what the globe predicts.
scales.
That's
The
not
globe
what the
does
globe
predict it
predicts.
that in certain scales it is negligible, and in higher scales it
No,
is more
look,
significant. That is
that's
what it
not what the globe predicts, bro. You can keep saying it, but the globe predicts 8 inches per
You're
mile
saying it's
squared.
not. Go ahead and explain.
8 inches per mile squared.
8 inches per mile squared.
That's right. So in 10 miles, the drop is 66 feet.
10 miles?
In 10 miles, the drop of the Earth from your line of sight should be down 66
I found
feet.
it. I found the place where the crazy people go.
Yeah, you're trying to throw your body into gears?
I finally found it. This is where they go.
You want to get muted, Nephilim free, or you want to act cordial? Oh, too late.
So you just don't under. It doesn't seem like you understand what the globe geometry actually predicts. The curve of the Earth should be easily measurable. Easily.
I think that it is easily measurable.
Okay, so who measured it?
Multiple people all around. I sent an article.
These guys always say the same shit. There's lots of people like who? Oh, let me Google it. Oh, there's some sticks and shadows. It's not measuring the curve of the Earth, dude.
How's it not? Like, there's so many examples of people measuring the curvature of the Earth.
Okay, then give me
As
one.
long as you keep saying it and not presenting anything, then I guess.
Who measured drop over distance?
It wasn't one.
I feel like you guys know more about it than I do, though. So I feel like
we do.
You guys should tell me like the main examples and why they're wrong. Because I just
No, you could at the very least say you don't know. Can you enlighten us? Enlighten you
why they're
or
wrong.
whatever. At the very least.
Like
I mean, yeah, that's what I'm saying.
right?
I don't know off the top of my head like the main examples of people measuring the Earth. Could you enlighten me on them?
That's because nobody's ever done it. No one's ever measured drop over distance. That's what we're trying to tell you.
Must have. I know that, but you must have heard people who claim to that are very like well known.
No, they don't.
How?
Because it's not a thing. You can't. If you have drop, then you don't have horizontal. Horizontal does not deviate from 0 degrees. It's that simple.
Yeah.
Okay. Welcome to Flat Earth.
Your
Yeah.
girlfriend. You can let it go, bro. It's okay.
Yeah, we did cover this. So they measure that there's no drop, and they say there's no drop, and you already talked about it. Because refraction picks it up to make it look flat. You understand? That's why I said it was ad hoc. Hey, I go out, I go to measure drop over distance. Oh shit, I didn't measure any drop over distance. There must be refraction making it perfectly look flat.
I think
every day of the week, no matter what body of water I go to, no matter who does the experiment, it's always the same. It just appears flat. Like the world is just a giant fucking optical illusion. It's really a globe, but it just appears flat because I live in a fucking giant lens, making everything just look flat.
That's not true. If I have more evidence, if I have more evidences of flatter surfaces than curvature, then I would believe more flatter surfaces. But I don't have that yet.
Evidence of
I have
curvature.
gotten a lot of stuff here to think about. I'm going to think about drop over distance. I still want the articles of the explanation.
It's still gonna be hard, Creanix, when you don't understand that flat is straight and level. When you're saying flat can be curved, you still have some things to figure out.
Well, if something from 5 feet away stays 0 degrees, but from 7 feet away it starts to become 0.1 or something.
Then it never was 0 degrees.
Right. But it's
okay, there it is.
Flat. Yeah.
You see how simple that is?
Yeah.
So if it's flat in one area, then it's going to be consistently flat.
Well, no.
It seems like he's subconsciously bringing up topography again.
If it's flat in one area, that means you measured it to tell, right? So if you measured it and it came out flat, that doesn't mean that everything will stay flat no matter what, because from 5 feet it was flat, and then from 7 feet it was 0.1 degrees.
What?
You know what refutes you? 0 degrees for everyone, everywhere at the ocean, at the water, at the surface. 0 degrees. Everyone has 0 degrees. It's our reference for the horizon. As long as you talk through everyone that starts talking, you will never hear them speaking.
I actually can listen while I talk, but go on.
Look, we have plenty of measurements of no drop over distance, and there are no globe measurements of drop over distance. That's what we're trying to tell you. The definitive
I feel like
evidence.
I've gotten all I need that I will use to process it all.
Let me give you an example of my favorite one, right? So the dude goes to a frozen lake. So the lake is completely frozen in the middle of the winter. He takes these road cones. All these road cones are the same size. He digs down through the snow, puts a road cone on the ice, drives a mile in his truck, puts another road cone down, drives another mile in his truck, puts another road cone down, drives another mile in his truck, puts a road cone down. He has a light, different color light on top of each of these road cones. He drives to 5 miles away from the first road cone. So now he has a road cone 5 miles, 6 miles, 7 miles, 8 miles away. He films these road cones from 6 inches off the ice. Now, each road cone, because they're farther away, should be dropped lower, right? Because of the curve of the Earth. The further it is away, the more down it should be because the Earth's curving down from his perspective.
I mean, not always more down. Like they're on the top of the cone, right? The light?
Yeah, yeah.
Like it will go down like
same
very
height.
near the end, but it'll be higher most of the time.
Okay, so the first road cone's supposed to be down 9 feet, and the last road cone's supposed to be down 27 feet. It's an exponential curve, dude.
I mean, I'd have to do math actually. I'd have to do the actual math.
But I'll just give you the ending because he films these right, and they're all in a straight line on the horizon, a perfectly straight line. When each road cone, not only should he not see any of the road cone lights at all, he shouldn't see them at all. But they should each one should appear lower than the other.
Yeah, I'll hear you. I'll remember that. I need time to process this stuff. So I'm a head out of here. I already have the refraction index of CO2, but I want the article of about that we talked about. The terrestrial, like I guess opacity or turbidity of the air.
I posted a while ago. I posted Southern Ocean Oceanography Guide link and the screenshot of it, and I posted the cosmologist guy.
Okay. Let me find those.
It's probably way up because it was like an hour and a half ago or something.
Yeah, I'm already up because I was looking for my article. I just like search this chat. Can I do that? I don't think I can.
Yeah, I don't know if they let you search the guest voice chats.
Yeah.
We shouldn't even be a guest voice chat anymore, dude. We should have like permanent status here.
Yeah, can somebody figure if that can happen, Indio?
All right, I got the guide.
Or I don't know, maybe Heretic can give a good word. Who knows? Just kind of let somebody know. Just, hey, man, we should be,
They probably got a vote on it. Some triggered mod will veto it.
Oh, cosmologist debate. Okay, got them both. Okay, thank you guys for talking with me. It was a really good time.
All right, man.
Bye con Dios.
All right, see it.
Dude, he was reminding me of Percent. He was so opportune.
Get your reps in today, Indio. You got like 2 pounds of flesh.
Dude, but like I took the same pound from the same place, man. Like I had to loop back around to get it again.
You had to place it. You had the same pound of flesh you extracted. You put it back in and took it back out again.
Yeah, man.
At least he was quiet. He was quiet. He wasn't all like, he didn't get all angry or anything. But boy, he was. Wow, she just like making up some shit on top of shit on top of shit.
Yeah, it's like Chef Indio over here, man. We're at a barbecue, man. He's just like handing out like leg quarters and fucking steaks.
Yeah, man. I've been very busy lately, so I haven't really been on that much. I gotta like be very efficient when I come in here. Cook them fast, right? Just burn it on both sides, raw in the middle.